All right. Hello, everyone. Welcome back to the stream. I'm Junchan, and today we are doing something very specific because that's something I actually need to do for tomorrow's stream, which is to solve this issue with this missing C library in our CUDA example, or more precisely, the accelerate examples that we're trying to run specifically for the n-body simulation. And yeah, I got quite far in setting it up, but there's still this problem with the C library. So let's dive in. So that's the error. We only actually get the last 10 log lines, so I need to find out how to display more logs. We're using Flakes, which is this approach we already taken in our other project, the GStreamer one. And so that's a modern experimental feature of Nix, but all of the things that come with it seem to radically improve both the user experience and the kind of guarantees that you have, because Flakes basically allow you to pin and lock the packages that come with the project, whereas that wasn't the case before. And so we're using this, and it turns out that it's also pretty nice with using the Haskell.nix approach to building Haskell projects. We started the other project, checking out Gabriel Gonzalez's approach to using Nix with Haskell. And what my coworkers mentioned there is that actually this approach depends on basically the way that the Nix or that the Haskell package ecosystem is included into Nix, which is very similar to the way that Stackage builds its sort of pinned version number for a given moment in time for all of the package ecosystem. In fact, it is based on that, I think, if I understand correctly. And so it's also evolving with both each or assigned to each version of Haskell, like the GHC compiler. So 8.6, 8.8 are in flight, 8.10 now, version 9 coming up. And but each version is also moving forward in time as the package and the compiler evolve. And so you're kind of pinned to a specific JC version and to a specific sort of stackage version. Whereas the Haskell.nix approach that we're taking here is more modular than this. And it's also more integrated in some sense. And that's why we're trying out at work. And so I'm actually, but we're not trying it with Flakes. So I'm trying it with Flakes. And it turns out that it's actually solving some of the issues that I had, which is, for instance, how to install tooling together with, I should go to the documentation, tooling together with the proper compiler and whatnot. And so specifically here, you can see that actually I lifted this straight from the example because there's an example with Flakes, which actually properly explains how to set up additional tools with your project, like the version of Cabal, HLint, and specifically what I'm really interested in is the Haskell language server, which gives you, feedback on compilation errors and, integration with your IDE. So in my case, Visual Studio Code. So that's not actually completely working. If you followed Saturday's stream, you know that I kind of tried to take a look at it, but didn't quite solve it. But yeah, that's to give you the picture. And what I really liked about this is that even though most of the other documentation that I could find didn't mention how to get Haskell language server, the Flakes one does. And to me, that's a sign that basically it's kind of future proofing. It means that probably the IOHK that's actually producing this library, and that's Haskell development in production with cryptocurrency focus, Cardano specifically, but also things like smart contracts and whatnot. They've pumped a lot of the smart Haskell people, and they, apart from their main product, gave back a bit to the community in the shape of, for instance, this approach to doing Haskell development. So that's reassuring in the sense that it's in use, and so hopefully it continue being in use. And I quite like the fact that the Flake.nix approach means that they're probably also at the leading edge of what's happening with the experimental feature of Nix, which, as I said, improve both UX and the behavior of Nix. And when I say UX, I basically mean the new Nix command that's supposed to be a sort of integration of Nix build, Nix env, and Nix instantiate. Like there's a whole little ecosystem of things that work differently, and Nix aims to put some order into this and succeeds quite well. In my view, and also actually with Nix Develop also makes even forays into being more performant than Nix Shell, for instance, which is another one of these command line tools that you need to know, that you needed to know before Nix became a thing. And flakes are meant to be poised to be coming into unstable soon as a main feature, and then in next release of Nix. Is it 2010? Maybe 20.10. We're at 2009, right? Yeah, that's for sort of the background in terms of what we're building and whatnot. And so yeah, just to say that I ran Nix Develop, and that goes and tries to build the project, and that's what spits out this error of missing C library CUDA. Okay, so that's where we are, and that's what we're trying to solve today. And so I thought I did quite a lot of the needed invocations to get this to work. So here the flake is drawing on the Haskell.nix flake Nix packages in the unstable version, some flake utils, basically reproducing what we have here. Then passing all of this to the output, and using flake utils to avoid to be a GRY, avoid repeating ourselves when specifying recipes for different operating systems. Then we add an overlay, which includes the Haskell.nix overlay. Haskell.nix already includes a number of overlays. And but we add our owns to this. So this is first item of this array, and then this other item of the array is also an overlay, and an overlay is actually a function of two arguments, one of which is what you'll get after you've applied the overlays, what you have before you apply the overlay. And so that's used to add some packages here. And that's the way in which actually it helped me solve something that was explained in this entry here. Oh, what? How come? Oh, I see. I think, yeah, my my output is a bit broken. Sorry, I just realized this. Let me fix that. There we go. That's it. Much better. Okay, yes. So I was pointing my mouse in this general direction here, mapping non-Haskell dependencies to Nix packages. That's basically what is being addressed by some of these lines here. Basically allowing to map a library that's declared as being LLVM-config in, I think the build depends of some Cabal library, some Haskell package that is a dependency that we use. And if we don't put this, actually, let me demonstrate it, it will complain about not having, not finding the LLVM config library or package. So it's a slightly different error than this error. That's why I'm also showing you, because I want to compare and try to understand a little bit better what's up. And so what do we have here? Right. Neither the Haskell package set or the Nix packages package set contain the tool llvm-config. Right. So I think this comes from the fact that Haskell.nix basically processes your either cabal file or stack files and then tries to analyze it to decide, oh, it seems like this library is depending on this bunch of system dependencies. Let me find them in the Nix packages and bring them in. And so here it's a message that's spitted out by that tooling. That the moment that tooling is getting into play, it realizes, hold on, I'm reading this stack.yaml file. It tells me that it wants llvm-config, but there's no such thing in the Nix packages. So when I was trying to troubleshoot this earlier, I was looking at this particular entry in the Haskell.nix documentation, which says cabal files may contain dependencies to external non-Haskell dependencies. And there's a bunch of cabal fields, or cabal file fields that you also find in stack that allow to define different type of dependencies. Build tool depends, I think, are just to compile. PKG config depends are libraries that are expected to be linkable to. So I think usually your final binary will be dynamically linked to these PKG config dependencies. Frameworks, I'm not exactly sure. Extra library is a bit like PKG config, but I think, yeah, slightly different for some reason. I don't actually have the details on this. We could read more about this. It could be that we end up actually having to need to read more in order to understand this error, troubleshoot the missing CUDA C library. But let's not do this just right now, because I just wanted to show you that the user may solve these issues themselves here by adding a package alias. For example, adding in a Nix overlay this what used to be self super and these days is becoming final prev. I mean, those are lambdas. You can name those things any way you want, except that I think Flakes seems to be expecting that you use final prev these days, just as consistency, which is good because that's one of the things I suppose that you suffer from, or that I feel like I suffer from in the Nix ecosystem, especially reading sort of like mostly old documentation or old even or people's Nix configuration files, is that because it's a very expressive programming language, people use a whole bunch of different idioms and different approaches and patterns to do the same things, and that can be confusing. So that will help for uptake and onboarding of new users, that these things are actually always the same. But you see here, Nix package .overlays is also defining aliases. So it's taking the ICU package from Nix packages and it's saying, well, you need to map it also to the ICU UC alias. So if in a cabal file I'll see ICU UC, I know that you actually mean the ICU package in Nix. So you can do the same thing here with this overlay. In here we have final prev and we add this llvm-config alias to llvm_9, which is how it's called in the Nix packages. All right, so that's all good. And according to this logic, then linking CUDA to the CUDA toolkit should work, except it doesn't. And that's what gives us the other error. Not only that, but you see that I've added some modules here. So modules apparently are meant to replace extra libraries here. So I think that's when you have some other tooling that is not necessarily dynamic linking libraries, but I get this error. Actually, I can show you because that will also help us. I'm going to just comment out the whole module section. What the error was here is I couldn't find some executable that's used to do CUDA compilation. So I think NVCC, I think. So that's an executable file, and it wasn't available. So what I deduce from that is that one or two things. Probably the library that uses this actually doesn't describe or doesn't declare CUDA as a runtime dependency, but maybe as an extra library, maybe. And so for some reason, then it doesn't have access to the binaries, to the executables. So let's double check here. Yeah, it says that it can't find NVCC. And that is the CUDA library. And so that's good because we actually have the CUDA library right by because we had, when we were trying to solve the same issue with Windows, we had to override the CUDA library. Sorry. So let's add this to our workspace. Sorry. And yeah, take a look. The cabal file, since we have access to it, that's really good. And see how CUDA is declared as a dependency. So it's declared as a build depends. And so the fact that it's declared as a build depends, it's declared as a build depends only of the NVIDIA device query library for some reason. But hold on, does this mean that it's not declared as a dependency for? No, it's not. Huh. Okay. Let me, I need to take a little break. I'll be right back. All right, I'm back. So let's dive right back in. Um, we are looking at this error. Well, I'm showing you different things that I've been doing, trying to address this compilation error I have for the accelerate examples, using Haskell to do GPU coding on an NVIDIA card with closed source drivers for now, until we move to Vulkan things. And so I was showing you some of the things I'd done on my flakes.nix file, and just commented out these modules to show you the errors which I solved by adding these modules. And yeah, now that I'm looking at it also, I see that I've added two things in here and I don't know which one actually worked. So we can try that out. Yeah, not putting this in meant that we get the error NVCC, make sure NVCC is available in your path. And so that, I think, well, first of all, how about we try and get more than the last 10 log lines, because that's going to be for sure limiting very fast if we try to troubleshoot this. And I think I tried some stuff like verbose before, but I don't think it worked. But let's try again. No, that's clearly there's clearly a different way. There's something that's very different from the, I was telling you about the Nix flakes and how it also comes together with a new CLI interface, where now there's a bunch of Nix space commands instead of the Nix dash suite of tools. And one of the other things that changed, which I suppose is an improvement in most cases, but for us is an issue right now, is the log, the way that the log is spit out to std out. They've done something a bit more modern where, you, especially for tracking sort of a multi-threaded output. So yeah, so I'm not sure how we recover either we recover the previous output style, or we somehow access maybe a log somewhere. Maybe a Nix daemon is logging somewhere. That might be the case, actually, now that I think of it. So let's maybe head to the terminal here, and then there is a Nix daemon command, multi-user support daemon. I think there is a watch command somewhere. Maybe let's search for this. So last 10 log lines, Nix develop how to see full log. Putting full logs on Nix builds. Show more than 10 lines like of output. This file Nix log. What? Oh no, that's a position, I think. It's or is it? Doesn't work if it's a dependency that failed. Oh, so you can just do Nix log to the derivation that failed. Okay, let's try that. Nix log and derivation that failed. Is that right? Yes, it is. It is. Okay, great. Excellent. We've just upgraded a tiny bit our Nix foo. Yay. Okay, so NVCC, it's at the setup phase. Because I think the difference between extra libraries and pkg config depends, and what are the other things we were looking at just a second ago that I already forgot. Right there. Build tool depends, pkg config depends, frameworks, and extra libraries. I think apart from defining whether they're more build time or runtime, I think they also relate to specific phases of the build. The check happens at different moments. So here, for instance, it looks like it's at the point where it says configuring library for CUDA. So CUDA is the name of the package. And I think when it says configuring library, it probably means configuring instead of by opposition as to configuring the executable. So a library being this. So I think it gets to the yeah, to this section of the Cabal file. What I'm surprised to see here, that although there's tons of, I mean, although the Nix device query depends on CUDA, that's not the case for the library, and that is baffling me. How come? Let's see if we have all the latest things and CUDA Haskell. There we go. 0.10.2, so that's the right one. And we didn't modify anything, right? It does say that the setup script does something. So maybe that's what replaces what Cabal is supposed to do, because there are some complexities involved with CUDA, something that maybe you saw in an earlier phase when we were compiling. It said something about the .build info file, and that's something that requires basically, I think, is a sort of interface between the libraries and then the tooling that CUDA would provide. And that build info file, actually, we have one here. Yeah, it describes linking options and, in fact, describes extra libraries. Ah, CUDA RT. Are we missing maybe these things with the CUDA toolkit? Could be. Interesting. Hold on. Clean up my glasses. Totally need to buy new glasses. They are falling apart. I've fixed the branch for the 4th time with super glue, and now they're totally pulling at my ear. And yeah, I've spilled a little bit of super glue on top of the lenses. For those of you who have really attention to detail, maybe you can see this, because I should have the focus really well set up with my camera. Okay, so yeah, and sorry for the lack of shaving and the crazy corona hair, if you have attention to detail. Right, so this all comes from, this is a generated file that comes from when we were trying to compile and build all this on a Windows machine. Right now, I suppose this would be the equivalent of this. No, not in this new style, maybe just in this then. Maybe not. Maybe actually, no, maybe, yeah, that's an interesting question. I suppose Nix doesn't build anything in the folder. It builds it in the store as it builds everything else. That makes sense. So where would this build info file go in that case? I think there's a way to find out. Well, in fact, the derivation name itself, which we could check here in the terminal. Oh, well, we didn't do it in terminal. We did it in here, right? Yeah, the log. I think the derivation itself contains the output files. And so, in fact, but it's all just one big line. But I suppose we could search here for build info. It's not there. That's, yeah. It's not in the derivation. At least it's not in the CUDA lib CUDA derivation. It might be in the CUDA toolkit derivation. I don't know, because it's generated by the setup script. So it could be that that setup script is not very Nix aware or not Nix aware at all. In that case, I wonder whether that's related to some of the problems we have. Because this is the setup script, and I think this is what the build info file it is. And this is what we saw gave this error, which is not the error we're trying to troubleshoot, but I'm exploring some of the adjacent problems that I had just to know the space a bit better. And so this tells me at the setup phase that NVCC is not available. And if we look at the CUDA.cabal file, it tells us a bunch of stuff about what the setup script is going to do. That it's going to look for the CUDA installation by checking, and in a specific order, the CUDA path environment variable. So that's interesting because our CUDA path is not set, I don't think. No. It was search NVCC on the path, and clearly when we do Nix develop, the path is also going to be develop specific. So I think there's not going to be anything in our global path here. We'll then check at user local CUDA. I don't think we install anything in this type of place. We don't even have a user local on NixOS. And search for CUDA path vxy environment variable for recent CUDA toolkit version x.y. Okay, so that's interesting. And because I definitely did come across similar issues about CUDA path and people solving some of the Nix building issues by specifying a CUDA path. So it could be that that's something we want to add in our, maybe in the overlays, or maybe some after build hook or something like that. I think that are kind of the keywords that I've seen to deal with some of these things. But it's interesting to see that whatever other ways we might explore, doing a module thing actually did solve it. So let's try and see whether it's the one or the other that solved it, because I added the pkg config later. So let's see whether it builds this way. The dash verbose, as we saw, doesn't do anything. And since I am actually on a terminal here, I think I will actually graduate to using a terminal for my builds, maybe with a slightly larger, I think that's the same size, slightly larger font size. Okay, so we're in Accelerate. Let's do Nix develop here. There we go. And that's immediate this time, which is perfect. I'm actually surprised that this thing takes time here, and maybe the shell in VS Code is also a little bit strange. So here it tells us what? It tells us that it found the CUDA toolkit, but it can't find this particular path. That's interesting. Ah, okay. So if I take a look at what's in there, what do we see? We see a lib instead of a lib64. But clearly it's linking to a 64-bit version. So shall we just add an alias for lib64 here? And why does it look for lib64? Is it the setup script that does this? It is, because it's expecting on a 64-bit machine that it should be lib64, which in this case is an error, or at least somewhat system dependent. Okay, I don't know what the proper morally justified Linux way to do this is supposed to be. But it's also strange that it's solved with the pkg config. So let's only have the pkg config. It could be that it's solved by, oh no, hold on. We are doing the pkg config thing right now. So pkg config doesn't solve it. So actually, I had some expectation that maybe it would work with pkg config because maybe in the include we'll have the PC file. The pkg config file. Is that in the, it could be in the lib. Okay. Stop. I don't see PC files here. Here. PC. PX. Message file directory. Oh, what? Hold on. Yeah. And so, well, maybe ls minus lar, and I'll grab .pc. How about that? Not what I was expecting. I guess the dot, maybe I should use quotes here. Well, quotes with the dot or with double quotes. Okay, I'm not sure. Maybe backslash the dot. Yeah, probably because I don't see any. What? What is that? Jar files? Oh, okay, maybe. Why not? Suppose. I suppose Java has the right to do CUDA as well. Okay, so no PC files, or maybe PC files get put in a specific place by Haskell.nix. Yeah, all of this being slightly non-standard because it's Nix and I'm used to Debian, and because it's Haskell.nix, which does another layer of things. Okay, so I suppose that if we just comment this and only put the lib, then we'll have some error. Which one is it? And will that teach us something? The stack.nix. By the way, yeah, the documentation on this. Oh, interesting. So I think actually having it as a lib, let us go further forward. I think because yeah, and so maybe pkg config here was my attempt of solving this further error, but it was only getting us to the place where we started, and which is the title of this video, in fact. Okay, missing or C library. So this is also meant to be at the setup phase, but let's do the log thing again. Oh, well, we don't have an Nix log here, and what we want is, I think, must be a different address, right? Yeah, it is a different address, as expected. And what did I do? Nix log, please. Oh, well, I was all proud of using my middle mouse button, but I think I clicked arrow afterwards. Okay. Oh, that's it. Okay. What? How come? Okay, I'm a little bit baffled here. So it failed. The builder failed. What looked like at the setup phase, so the same phase. Found CUDA toolkit setup phase, yeah, it looks like the same phase, but for some reason that's not appearing in this log, whereas We just copied this. And that looks correct. KRG data, yeah. Why would it not appear in this log? Let's look at the noise a little bit before that. Configure flags do show up. They're here. Ah, okay. And I suppose they, yeah, right. They show in that way. Okay. It's a thing. Um, oh, prefix is CUDA leap CUDA. Ah, yeah. Oh well, that's the destination in the store. That's not the derivation. So meaning, oh boy, that's not good. I can't go back in my. Oh, I dislike this. Well, let's create a new tab and do our Nix log things in here if we can, and redo Nix dev up here. Okay, yeah. Maybe there's a version. Let's do Nix log help or dash help. There we go. There a way to not be thrown into interactive mode somehow? Get a bit log from a specific binary cache. Oh wow, remote logging. That's cool. Have a specific path. Uh-huh. Derivation file impure and access. Well, that's sad. No way to specify that we don't want it to be interactive. That I can see at least. So let's do this. And so it unpacks the source archive. That's does its sandboxing things. Does some patching. Starts the configuring, which for Haskell means defining the configuration flags. I think for GHC. And then some profiling flag seems to be wrong, but that's fine. And then it finds the CUDA toolkit, right? So I think that's the setup, which finds the toolkit and reports it back to us. Found CUDA toolkit. Let's find CUDA install path. So it did try to locate it, and it did locate it. I wonder how it located it. Meaning, was it an environment variable? We don't really know from this log. It's not necessarily super important, but let's take another look. I kind of want to go that route. Extra libs, packagedb. It creates a package.conf.d. I think I remember my colleague mentioning that somehow Haskell.nix makes the dependency available through the package database, the GHC, the Cabal, GHC, I think it's GHC, the package database. Okay. So does it find this through these build arguments, the configuration arguments, or through some environment variable that's set by Nix when we depend on CUDA? when, in fact, when CUDA toolkit, so I think I found my own solution, or at least a place to look. If we look at the CUDA toolkit derivation, then it should tell us what it does. And we are installing CUDA toolkit 10.2. So it's actually, I think, right? Yeah, 10.2. So, oh, right. I think in the flake we pin it, right? Yeah, we pin it to 10.2. So it calls a common, but with a bunch of stuff. So the smartness must be in the common. And that's just call package. Oh, dash common.nix. So it's common.nix from here. So what it does for all CUDA toolkits, it registers ourselves to the program. Oh, that's sweet. We are actually registered, but I see, because there is a registration wall there to download the libraries. Retrieve the CUDA toolkit at blah / CUDA toolkit and run the following command in the download directory. Nix prefetch blah. Nix prefetch is the standard way to get binary dependencies. And so unpacking, it does things with samples and package folder and a bunch of patches, and then doing install it does version dependent things. Find some stuff, move NVVM to the output folder. But I suppose NVCC as well, right? Yeah, well, it's set the compiler for NVCC profile. For here, I think that will search for stuff in NVVM and copy them to the output, I think. And does it set some path? It's set LD library path. Yeah, wrapping stuff. And then our path prefix up. I think that's, yeah, that's for patching dynamic libraries so that they find libraries in the Nix way. And set our path so that liquid and other libraries in run OpenGL driver lib can be found. This came up quite a bit when I was searching for troubleshooting tips. See the explanation in add OpenGL run path. Don't try to figure out which library really need it. Just patch all, but not the stub libraries. Not that force our path. Prevents changing our path to run path. I'm not sure what all that stuff is, but okay. And that's what we have for path. Yeah. This path samples. So it's not based on the path. It's not how we find the library. Found CUDA toolkit, but I don't think it's based on the path. If it's not based on the path, then I wonder how it finds it. CUDA path NixOS. Yeah, so this recipe has export CUDA path, which is exactly what I was expecting to see. But this is, I think, really not very maintained. This is also the talk section. Export path, CUDA path. CACC wouldn't be found. Oh. So he added this. But I think that's not a very Nix way to do things, if I understand correctly. CUDA make this work until I unset CUDA home, but conflicting with CUDA path, making CUDA devices undiscoverable. That's not exactly our problem. How can I find out? We don't have CUDA path, right? No, we don't have CUDA path. I mean, okay. Sorry, I'm doing something maybe probably doesn't need doing, but I want to check that I also don't have CUDA path here. I don't. And though NVIDIA SMI should work, although usually it requires me to try it first from root. But no, this time it works. But the CUDA version is different. So that's possibly an area worth taking a look at. Or it could be a problem. We might need to downgrade our driver, but I would expect that the 10.2 driver would work, that there would be some backward compatibility. Shall we double check that? CUDA toolkits backward compatibility. Yes. But not across major version changes. CUDA 11 application will be compatible with 11, 11.1. CUDA application typically statically include all the libraries, blah, blah, blah. They don't. I mean, I suppose this would be something that we're running afterwards. Once we successfully built everything, then it will probably say, sorry, I'm driver 10.2, I can't talk to your card. And then we'll need to, what's this? Forward compatible feature driver support matrix. CUDA forward compatible upgrade, 10.2. CUDA OpenGL Vulkan interrupt? No. 10.2 with 4.8, okay. Oh, right. Driver 45546, which is between these two, and it's not compatible with 10.2. So we're probably going to have to go back to 440. Yeah, no, they're not compatible across major version upgrades. Too bad for us. Yeah, I'm now contemplating the amount of work in upgrading the CUDA library to CUDA 11, and that's just going to be fairly slow for me because I don't know much. I haven't done any wiring of like a C-based library like that. So probably the easiest way is to revert. Oh, hey, hello and good day. I was hoping that I had some way to actually check the chat, but apparently it's not working. So I am going to have to try it again, try something different. I think it worked last time, so let's try this. Window projector, and put this here. Okay. Yeah, I'm working on preparing tomorrow's stream where I'm going to do more CUDA things. And yeah, I had this issue with configuring CUDA. And now I'm just realizing probably also that I'm going to have to revert to an earlier version of the driver. So yeah, it is what it is. And but that's okay. And there, just to pop back the stack here, we see that some folks seem to be making sure that they export the CUDA path as part of this old recipe. There, I wish there was a date in this talk page. This should be mandatory. 11 February 2021. Well, it's very much still relevant. These earlier entries weren't dated, but this last one is. Making progress understanding the errors. You know, hopefully it's not completely straightforward. There's a number of things I'm not very familiar with, so I have to take it fairly slowly. And it looks like my overlay is actually working, so that's good news. Okay, so let's see. So whatever the way that, so what seems to have allowed for the toolkit to be found is this invocation here to declare CUDA toolkit 10.2 as a lib. And I should point out that this is part of something that is actually undocumented in the Haskell.nix ecosystem. It's module options, which is specified. Where is it actually? I think it's specified in mapping non-Haskell dependency. Yeah, right there. If a component is missing a dependency, it can be added via modules, for instance, blah. And then some other documentation page says, well, actually some other documentation page have a module highlighted and you click to it and it just falls into the ether. And in fact, this module option page is available, but on this GitHub page, what seems to be automatically generated. Yeah, automatically generated from Nix sources. And the components, components.library, yeah, right there. Component.library. In fact, component.library.lib. Holy moly, there's so many options. .libs, right there. This option has no description. Wonderful. And even library, the top level thing, .library, this option has no description. And also it's packages dot blah. So I think you're supposed to say which Haskell package you're referring to. I don't know, to be honest. And then I would also expect that this overlay, that this would have solved the issue somehow, but it didn't. But maybe the reason it didn't is because CUDA is not listed in the library dependencies as it should normally be. That it's only listed as a build depends for the executable, but not for the library, because it has this whole complex setup thing. So in that case, it makes sense that we would need to override, add another layer because the setup is non-standard. So the whole Stack.nix and Cabal.nix tooling can figure out that it's actually doing all of these complex things to find out about the CUDA path. So we need to compensate somewhat for that. So I think that's fair. And also accounted for in the Haskell.nix way of doing things, except the Haskell.nix way of doing things is also not ideally documented, as I just mentioned. So there is this bunch of documentation right there, right, that says it replaces the extra libraries dependencies. And so I think it's time to read some Cabal documentation. And that doesn't make the right way. Okay, extra libraries. Okay, package descriptions, extra library field. A list of extra libraries to link with. So that doesn't even really necessarily fit what we're talking about. And this is using the libs field as well. And despite using the libs field, I mean, the reason why this is puzzling me is that if it's about linking, then it doesn't fit the error that we had when we were commenting this out, which seemed to be more about, I mean, which was clearly more about not finding a particular executable, not finding a VCC. So it seemed much less like linking and much more like just environment variables being defined. Since it seems, although we couldn't figure out what exactly allowed the CUDA to be found, it presumably looked through all these things and found one. And VCC in the path, I suppose that could be the way that it finds it. Actually, I didn't necessarily consider that, but I suppose that when you do Nix develop, then it's accumulating all of the build products into the path. So then you would expect that that then it depends on the phase at which the build or the Nix build occurs, because after the Nix build occurs, then you would expect the path to include the tooling that's provided by the library. So this might be, in fact, the reason why this line doesn't really work. So let's try a combination I don't think we've tried, which is to put this line here, put the library.lib, so the extra libraries dependency, but not do the aliasing, and see what that tells us. If we get to the same point, then I suppose it validates what I'm saying. But it could be that we have an explicit dependency somewhere on CUDA, even though it's not the case here. Yeah, we get to the same place. So actually, this is sufficient to get us to the same error that we started with when we had all of those things commented. So I think it is a question of when things are built. That sort of makes me want to cheat and install CUDA toolkit in the environment. If I do that, then I can't contribute back my flake file. So let's not do that. And I also kind of give up on trying to understand better the Haskell.nix interaction in Haskell.nix. Okay, so we get to the same point, which I think makes sense, which I think is an additional data point that reinforces my thinking that here we update the path. I'd love to be able to somewhat introspect that. So the fact that Nix develop replaces the Nix shell, but that I can't be yet in the shell, means that I can't check the path, because now the path is, I think, the path that's outside Nix develop, right? Well, actually I say that, but no, I have NVCC. So actually my path is set up properly. And so I do have NVCC on my path. And so hold on, if I check, if I start a new shell, do I have NVCC? I do. But I do, but I think that's because I've installed it in my configuration.nix. Yeah, I have it installed as a system package, but I think that it's not the one that is being found when setup.hs is ran. And I'm going to check this assumption. And the reason why I say that is because I think that those builds are sandboxed. And that means that they're meant to be reproducible and yeah, irrespective of what the containing environment is like. It's supposed to have all of the things that are needed during the build in order to create the products. That's part of the Nix philosophy as I understand it. So let's execute, let's remove the CUDA toolkit from our system environment. And rebuild our system the Nix way. And if this works correctly, then I should not have NVCC in the path anymore in that bash shell. And however, it should build the same way with Nix Develop, because Nix Develop has the CUDA toolkit as a dependency as listed in the flake. And right now, in that shape. And now I suspect that there might be a way to declare this maybe differently. I'm not sure how yet. But we're doing some rebuilding. It could be that we're fetching some stuff from a stable as well, which is not ideal, I think. And so NVCC, yeah, we don't have it in the path anymore. And so assumption checked. And then if we do Nix Develop, my expectation is that we'll still reach the same point. And indeed, we still reach the same point. So my understanding of the sandboxing is, at least on this point, it's correct. And it means that doing this invocation puts NVCC in the path. And that means that that's sufficient for our setup script in the CUDA library to find the CUDA toolkit as part of that second search strategy. Awesome. Now what? Now let's look at the log again. And now it must be, is it a different path? GQL? No, it's the same path. So yeah, so that's good. Build log the RVB, yeah. Yeah, okay. So that's the complete log. We only see this bit from the 10 last lines, but with the nixlog command and passing the derivation, we see all the things. So we found the toolkit at this path, and is it because you just did which? Oh, well, I can't do which MVCC anymore because I don't have MVCC in the path. Oh, it's all good. It's all good. Okay, you found it. Fine. What next? Storing parameter to good building for generated. That's awesome. I wonder where that goes. Let's look at the derivation itself. And yeah, there's a bunch of paths here. This is really hard to read. I wish there was a way to quickly print derivations. And I'm sure there is. So Nix pretty print DRV files. Nix derivation pretty pp-drv. I suppose we can requires Nix package manager. Does it have a flake? It doesn't. And are we supposed to clone and build it? Sure, why not? Let's do it. Put this in our workshop. Oh, actually, I copied the whole thing. Yeah, I did. We go into it and we Nix build. And then we'll install it in our environment. it uses Haskell. Yep. Parsers, state of the art, right? State of the Haskell ecosystem. Parsers, state of the art. Best in class for parsing and pretty printing. Right, so it's doing the things. And some tests, and we install, and we do pp.drv, I think. So we go back to, well, we don't need to go back anywhere because we should have this as a bash history, and we do pp.drv. Ta-da! And yeah, we can read it finally. Build inputs, ready, run hook, pre-build, Likuda, Nix build cores. Interesting. Configure phase. Configure phase. Okay, I guess we can Xlog here. And right. GQLZ6. Q. GQLZ6. W. That's strange. Usually that works quite well. That was a tip given by Gabriel Gonzalez. We were just watching the Soto page, which he contributed, and he also did a talk on Nix, and explained that actually you can use the first characters if you just read them to automatically go where you need to go. But apparently I'm failing to do that. GQLZ6. GQLZ6. Maybe maybe it's just it could be that yeah, no, I don't know what's up. No, don't too much GQL. So that works there, but clearly what's going on there? Well, how come I can't? Let's just see. I was just looking at it just a second ago. I could just copy paste, right? But where's the fun in that? Okay, this is a mystery. Okay, so this works. Is this a 1? No, it's not. What? Why is it working now? GQL. And then even that works. GQL. I don't know what I was doing before. I suppose. Oh, I'm doing more now, not Nixlog. So is it that auto-completion doesn't happen with Nixlog? GQLZ. Ah, yeah, that's where it is. There's no auto-completion here. Okay, okay. All right, so so we have the Nixlog, and I wanted to check where we were in the order of things. So unpacking is one particular phase like there's some phase that show up here, right? There's a build phase and a configure phase and the install phase seem to be alphabetically ordered, in fact, so probably not ordered uh, by actual execution order. So yeah, so unpacking, just going to fetch some stuff. Configuring, that looks like that's the configure phase, right? Pre-configure, configure flags. Check this out. This run hook. So yeah, configure flags right there. Um, let's see. So I think this is created by Stack.nix from the Haskell.nix tooling. I think it reads the Haskell, the Cabal file, and it outputs this. So the code for doing this must exist in the Haskell.nix repo. And let's go check that out because I think we need to understand these things a little bit better. And so I will have my theory is right. I will have something like configure flags here somewhere in the code. I have many configure flags, but I don't see some which say configure flags in text. Oh, hold on. Yeah, no, the derivation. So, I do expect to see configure flags, but I don't. But the GitHub search is terrible. So this is for ad hoc and G-object. Oh, G-object introspection, right? Make config files, Windows, muscle, package quirks, Bootstrap. JCGS, compilation, configured source, plan. Plan is not a bad. The plan, that is a package set description, like an LTS set or plan.nix, right from plain.json, will produce a structure that looks like blah. No, I think this is different. This is the Cabal build plan. So it's not that. It's like a dependency graph, I think. So we don't know yet where the pre-configure run hook comes. Okay, let's try pre-configure them, since that's in one word, so probably easier to find. That's a string right there. Well, it could be that these symbols are in fact not strings, that they're printed as symbols. That's very, very well possible. In fact, run hook. Well, hold on, but this is the ad hoc stuff, but this is exactly what we would expect. Configure phase, run hook preconfigure, echo configure flags. Yeah, exactly what we want. But this is in the ad hoc builder, which is the documentation builder. Why? I mean, maybe there's haddock related stuff in there, why not? But why is that the main thing that comes? I guess maybe it's not, but run hook. But the run hook preconfigure thing, I only see it show up as such here. And echo configure flag, that looks exactly like what we want. So it could be that this is actually for haddock building. That's strange. Or is it that the haddock builder is sure does the haddock documentation, but in fact is really a builder? There's a setup builder. Do we know? How would we know what kind of builder we are? So that's all about sort of introspecting or observing the results of the Haskell.nix transformation, of the stack-to-nix transformation. Let's see if the documentation says something about that. Scaffolding, but that's not about how it works. Pinning Haskell.nix versions, why not? But that's not also what we're interested in. Creating a development environment. Sure, but that's not going to help us. So I'm not sure whether it's the tutorial. Maybe it's the architecture that instead we want to look at. Haskell.nix. The runtime system for this Haskell infrastructure contains the component builder. Okay, there are multiple components that play a part in the Haskell.nix infrastructure. Nix tools, Haskell.nix, package.nix, and stackage.nix. Nix tool have this stack-to-nix, plan-to-nix, cabal-to-nix. Stack-to-nix depend on stack packages.nix, plan-to-nix on plan.nix, cabal-to-nix on package.nix. Those are all linked to package.nix, and Haskell.nix is a package.nix. Is that the architecture of the repo? Not really, right? Nix tool is a Haskell package that provides the following tool. Might or might not be in the Haskell.nix repo. Haskell.nix is the runtime system for this Haskell infrastructure. I'm tempted to try stack-to-nix and see what that does. Stack-to-nix. Hold on, did I spell it correctly? Yeah. There is a link. There we go, Nix tools. Set of Haskell.nix tools to integrate Haskell projects into Nix build environment. Or yet another conversion. Cabal-to-nix has served the Nix community. Some shortcomings. Explore the space of a very simple Cabal conversion into a Nix expression and then doing the lifting in Nix. I understand that now. Building Cabal new build and stack-to-nix as a main.hs file here. So do I have this installed? No. So nixenv -i a NixTools. Haskell packages .nixtool. Not Haskell doesn't exist, and neither does this. Name collision. Okay, I see. Yeah, that's what do I have in my NixOS home? I do have Kebab.nix. Interesting. Well, then let's just, well, I suppose, let's make it temporary for now. And let's try stack2nix. Not found. My colleague explained to me that using A as the attribute, if you know that it's a root package, it's going to be O1. So much faster. Whereas if you don't do A, then it's going to recurse through the whole of Nix packages. And therefore it takes much more time. And it's marked as broken. Zero two three. Packages. NixOS Cabal. 01. Stack2nix here. But HS source does dear stack2nix. Yeah, this is suspicious. Let's see if it's a root project. It's not. Search for it. Yeah, and we can also use Nix search, which is part of this new tooling, an experimental UX, and do stack2nix here. Yeah, I need to say in the Nix packages. Matches the derivation here. Okay, let's see whether Nix search actually finds something. It doesn't, and stack2nix it does. It's the 023 version that's supposedly broken. Let's search for Nix tools. Not found. Documentation. Oh, this is stack. Okay. This is Cabal. And this is Nix. Haskell.nix. Command line tools. Stack2nix. We've done this, but let's see. Is it in creating a development environment? Development shell. Yeah, I didn't hallucinate, right? I don't have stack2nix. Nix REPL. repository lumping package. Yeah, command line tools, but no instruction on how to install the command line tools. Installing Nix tools. You got to be an expert at reading documentation. That is not easy. Why would you put the installation instructions in the dev notes? Oh boy. Okay, I'll do a good Samaritan action. Right. Command line tools. So in Nix tools. Boom. Drive by contribution. Done. Okay, so has it installed? It has, and then I think nix-i-nt. And then we have back to Nix. Wonderful. And then we look at how we use it. And it takes, well, it looks like it doesn't need anything, in fact. Or it doesn't need the output yet. Okay, so we'll create like a S2N repo from it. There we go. And here's where it creates default and packages. So that's what you meant by architecture here. It creates a default file and a packages file. Okay. And the default file has imported Nix sources, Nix packages for particular. Right. I think. Yeah, right. That will generate something that should be able to be ran by Nix build. And it uses Haskell.nix itself from master. And then in Haskell.nix, there's sources for a certain version of Nix packages. Also something that's called Nix packages args that is used by what? It's used, I think it's passed to the build recipe somehow. I forget which one. Is it this one? Okay, well, I'm not clear where it's passed, but yeah, I've seen this before. Oh, actually, it's passed to Nix packages 2003, I think. That's actually an argument to Nix package args is an argument to Nix packages 2003, I think. Okay, and then it's well, where is packages.nix gotten? It's gotten from here, so it's put into the stack-package field. And so something is going to make some stack package, some stack nix expression, the derivation from this package.nix file. Package.nix file contains all of that goodness that is definitely now related to the cabal file. And so it's all of the dependencies. And actually, that makes me curious about something. Command line tools, stack file, ignore the package YAML file. Yeah, that's interesting. The reason why I'm picking up on this is because I made my stack file such that, well, actually it has all of the dependencies here. Interesting. I think when I was on Windows, maybe I ended up building with Cabal. And I was aiming to build specifically the n-body example, which doesn't depend on, for instance, LLVM PTX. Sorry, LLVM native. I think it depends on LLVM PTX, but not on LLVM native, which is for the CPU. And so I ended up being able to pass build flags such that it knew that because it was running the n-body example and that it defined in the cabal file as not needing those other libraries with the build depends, only uses oh yeah, it did this differently actually. It did this with these flags. Oh no, it's worse than this. I had to manually specify that I didn't want the flag for LLVM CPU to be true. And I did that in the cabal.project file. I said, no, don't build minus LLVM CPU, but plus LLVM PTX. And so apparently that's not being picked up, which is where I wanted to get by stack.nix actually. Let's see if it's picked up by cabal.nix, since we have the tools. Cabal.nix minus O C2M, right? With the dot, please. Oh, the different interface. Okay. And in this case, it actually also doesn't care about the cabal.project file. It just picks up whatever is in the .cabal file, which has these flags true by default, so it makes them true by default. Okay. And is there an option? Some help? There isn't. And how about here? That's it. Writes to the ZDR as a Nix expression for the given cabal package. I see. Okay. And then the stack.yaml, same principle. I think I have somewhere in the stack.yaml file flags, which are set very specifically here. But I think, in fact, it could be that when I tried this, it didn't work, and I had to use the cabal way. Because maybe these flags are not passed one-to-one to cabal by stack. I'm not sure here. but visibly it's also not being picked up by Stack.nix. Although, to be fair, I haven't looked at this accelerate example.nix here, and yeah, it for some reason, even though I have VM CPU to false specifically here, and let's see, red expose X, does that show up? That doesn't show up. Is this the right stack file we're picking up? Or is this not properly handled? Does this come? So we have to look at the have to look at the code. Do I want to do that? I mean, we're using this at work, and I do want to understand it better. But on the other hand, I also want to get back to this CUDA compilation problem. Decisions. Default stack.yaml. So it is supposed to be reading the stack.yaml. Although my Git is dirty. But stack.yaml is added, right? Yes. It's not committed, but it's added. That should be enough. Because I think I couldn't even run things when I didn't have it added. So it's been added with all these flags. So why these flags? Okay, I'm going to try something. And hold on, flags accelerate examples here. So I suppose that they show up as flags here because they are accelerate example. Okay, but let's try something. Let's try to comment out this guy, for instance. And I think, well, I don't think we need to commit actually. And we can run Stack.nix from here into S2N. And are you going to be okay? Oh, -O. And let's go check it out. And it's still there. So where is it picking that up from? Let's do a few things, sanity checking. Let's do this again. Make sure it wasn't somewhere in cache. It wasn't. Let's again delete it, just sanity checking, and commit or add at least our new stack changes, and then do command again, and VM CPU true. So I bet you this is coming from the cabal file. And I didn't want to change the default from the cabal file, but it looks like I'm going to have to, because that's exactly what cabal project files are for. They're meant to allow you to specify things that are local to you and that won't affect the actual packet you're working with. So let's test the assumption, and VM CPU false. So yeah, okay. So I didn't need to read the code. I know how it works. I could just black box poke at it. Cool. What have we learned? We have learned how Haskell.nix does a little bit of its kitchen by playing with the Stack.nix tool directly. And one of the things we wanted to see is how it specifies the build phases based on that Stack.nix output. And all of these things seems to be somewhat like wrapping the package that are defined in the our repo here to make them available. And same thing with the packages. Yeah, I think I get it. That's exactly what this this sentence there that we did read, which is in the architecture, I think. Yes. Right. So without Haskell.nix, the expression generated by either of the Nix tools makes little sense of their own, because that's the workhorse. Haskell.nix expressions basically take this as input and then process them to create all of the Nixisms meant that are useful for the build. So this is just like a declarative, like this is the stack file or the cabal file translated into a way that's going to be the input for all of the Haskell.nix transformations. So we need to understand more of the Haskell.nix transformations themselves in order to know what is being done with all of this. And so I think the entry point is something like make stack package set. And I think there's other entry points like project prime, I think it's called SHA-4 maybe, but yeah, packages.haskell.nix.project is one, and then there's also a project prime. I think that's the one that's used in the Flakes example. I don't know how to, yeah, where is the Flakes example stowed? Getting started with Flakes, where is that? That's supposed to be a top level thing, but it's not appearing in the table of contents. Okay, another drive-by contribution. I think this should probably go into, let's say, the dev notes, and I think this needs just to be referenced, probably not in the file itself, but in the wherever the TOC is. It's probably at the root somewhere. I think here. Nope. Oh, so maybe the root then. And kdocs. Getting started with Flakes. Very useful to have. Therefore, should definitely be in the documentation. And it's in, oh, it's in tutorials. Hold on. Was it in tutorials and I didn't see it? Nope, it's not. So let's put it in tutorials. That's where it was supposed to be. And yeah, I should just be there. Okay, and what's the URL for it? What's the URL for it? There we go. Publish the Flakes documentation in the TOC. Why not? Okay. And yes, so we wanted to look at the Flakes. The fact that I wanted to look at the Flakes is because I think it uses the project prime thing, which is maybe specifically for Flakes. And so let's look at where those functions are described. And if you project prime, at least, well, they're not here. Haskell.nix, not here. Kebab prime, I think that's, well, Kebab 22. Sound right? Oh boy. Okay, yeah, project is too big of a hit. MK stack package set, that should be much easier, and let's not close that. Good documentation makes the world a better place. It does, doesn't it? Yes. Let's see what the Haskell.nix people say. But yeah, I think those are good contributions to make. And doing this while I'm streaming is, you know, a bit of a little push to do things correctly, right? Okay, so no, I didn't want to search in the whole of GitHub. I want to just search here, and there we go. Let packages know this is using it. This is using the function, and here we go. So it was in overlays Haskell.nix. Okay, which is, by the way, the one that we import in our flake right here. Haskell.nix.overlay is what gives us the Haskell.nix field, which we can then use in here, Haskell.nix project. Okay. So, and there's quite a bit of documentation here, actually. That's nice. Default module will always be included. They're here to be overridden and added to by other overlays. Okay. Sources, NIF-based source pins. Right, because we're looking at, well, we're not looking at projects or make package set or project prime or anything like that. We're looking at some of the other stuff that's hanging out at the roots of the overlay. And so we do want to search here for project prime. There's a Cabal project prime, and there's a stack project prime, and there's a project prime. And yeah, I think the project prime basically is a stack versus Cabal detector layer, and it then routes to stack project prime or Cabal project prime. So let's go check out stack project prime. It's just right here. And well, apparently the syntax highlighter is going a little bit wild here. And stack project prime. Call project results, call stack to Nix. Well, call stack to Nix, we know what that does. And I suppose that the call project results, indeed, as we said, it's the input to the Haskell.nix thing, and we can see this right there. Wonderful. And then we generate a stack cache, okay. And then in the thing, we say that it's a project, and whatever project's supposed to be. I think probably that builds a derivation, something like that. So it makes a package set, which is the thing that we saw in here. And import and filter projects, package def extras, package def extras. And it creates a package set. So I think that's like a plan, I think. Package set is the terminology for stack, I believe. So I think it's basically all of these plus all of their dependencies and pinned to a specific version. And then that's given to the project. The project results are stored into stack.nix. No, right, hold on. I think this must be the workhorse here. This is the function that takes all of these arguments probably in order to make a derivation. And so it's passing the stack.nix results, the stack2nix results here. It's gotten from call project results, some tools that are coming from the Haskell.nix top level project, I think, or build packages. So wherever that is, or we define higher up. Yeah, with which compiler we're using. So yeah, these config options, I think we set them in flake.nix, in fact. Right, compiler nix name here. That's the stuff that we pass as options to Project Prime. So they're being passed down as args. They're being passed down as, I think this ... means whatever else is being passed, just pass it with its name. And so I suppose it means that Nix name is available in that way. Maybe? Package set makes it doesn't really pan out because it seems to be in the package set namespace here. Mix package. Although it does get the args from here, and it passes args. So args is the pin name for the whole record. So args, it's compiler nix name right there. Yeah, so compiler nix name indeed is gotten. So this is indeed a wildcard pattern match on all the fields for that record. So the fact that we have compiler nix name passed as an argument to Project Prime, which passes them right back to stack Project Prime, means that we'll have a compiler nix name in here, and we can access it right there as compiler nix name. And that's probably then going to set that config thing and that compiler make stack package set is going to do that. So we have now the compiler nix name available nicely stored away in that place. Okay. Then we have roots and a project function, which takes a Haskell.nix and returns a stack project prime. Hold on one second. Stack project prime. Is this recursive? It might very well be. It might very well be. Because I suppose this is going to do the whole, this is going to build the whole tree. Maybe. So I think the truth though is that add project and package ATTRs is where the smarts are going to be. So let's go check out where that's defined. It's defined right here. Take Has packages from the raw project and update all the packages and components so they have a .project attribute and as well as a .package attribute on the components. That's a very operational description. It doesn't say what really it's meant to do. It just says that it's adding a bunch of data to the thing without telling us what the data is. Okay, but there's a fixed point there, so there is recursion for sure. And look at the component. Yeah, this is hard to read. Take a package name and a package and does some stuff to it. So that it maps over, I guess, final.lib. I know final.lib map at CTR. That's just the map standard library map function, and that's applied to this value. This is the map function. Hold on, where am I? Here. This is the map function, and it's applied to this value. ignoring SHA-4. This is not pretty. Ignoring SHA-4, and it is not pretty, and it explains, I think, some of my confusion as well. But it's weird. Oh, here, SHA-4. Yeah, it's harder to see in this format. It's easier to see in the, so not this format, but the format that's in the documentation, in the regular getting started, and we are page here, regular getting started, are actually in the development environment bit. Yeah, you have a bunch of packages. No, still not that. SHA-4. Yeah, I'm not sure what my point is here. I think I wanted to say that there's some stuff that hovers at the root level, like this stuff, like LVM config, and that's clearly a package. But it goes together with this accelerate example project, which seems like that's not a package, but maybe that's just the name that we give to our current project in that kind of package. That kind of packagey definition way, maybe, because there's no way to pattern match on that stuff. So it seems to mean that there are some attributes here that are not meant to be packages. So we remove them from has packages, and then we loop on them. And I suppose, so is that going to be all the top levels? I think it's going to be the top level. Well, maybe these packages too. Maybe these will go into this map as package name and package prime. Or it's just the stuff that generated from project here. Yeah, I don't know. It's not completely clear. Also, I don't see any reference to modules here, but it's probably one level down. It's been passed as an argument, so it should still be passed. Let's get our project prime. Stack project prime was right there. Yeah, we pass it as project args, those arguments. So this LRVM is an argument, project argument. And the project argument, is it curiously, oh no, it is used. So yeah, okay, the indentation here is not necessarily super clear. So these are a bunch of things that are all part of that open curly brace right there. So in the add project and package add TTRs function. So yeah, so I was kind of expecting that everything will happen here, but in fact, there's a lot more that happens in the workhorse function all the way down to there. Okay, so that's good. And then, yeah, our project args were here in project cross. That sounds like that's for cross compilation. And then they just show up there. So, So when is this stuff being passed? Oh, well, the truth is this is an overlay. So this is the logic of an overlay. So it's just going to attach llvm-config to the package's root, so that packages.llvm-config resolves to something. So it's not really, it's just a, I guess you could say, aliasing, embedded aliasing machinery of Nix itself via overlays. It's not part of the machinery from Haskell.nix. Haskell.nix just receives these packages and does its mapping. And if you happen to have defined the alias, it's be like, oh, okay, you get the alias, I'll use it. So which explains why this also didn't work, because this is really saying if any package is depending on CUDA, then map it to CUDA toolkit. But as we saw, CUDA 0.10.2 doesn't explicitly in its cabal file depend on CUDA, and because it has all of this setup machinery to do that. So it makes sense that we don't need this here, and that's not going to do anything. Also, it also explained that it's not going to do anything, but also because it's lazy. Because Nix being lazy, the fact that we add CUDA here doesn't mean that it's going to be built, and i.e. that it's going to put NVCC in the path. Because if nothing depends on CUDA, then it's not going to be instantiated. And so in fact, even if it then depends on the build order, because if we have a library downstream of the CUDA lib that we're trying to build right now, that would maybe depend on CUDA, then possibly then at this point, it wouldn't put NVCC in the path. So I imagine that then there might be maybe some ordering magic that would happen. But in our case, it doesn't. And so I think we can just get rid of that line. And since we're cleaning up, let's get rid of I kind of like having this, because I actually kept this just specifically because there were a bit of a pin for me to think about trying to understand this stuff. And now we are kind of understanding that better because we know how compiler Nix name gets passed. And if I had deleted that, then I wouldn't have had this example handy. So thank you, past June, for keeping this line. And I'll keep it just a little bit more because I don't think I've completely understood things. Okay, so where are we now? We have delved deeper into how Haskell.nix works. I think I understand, yeah, definitely much more. And I kind of want to get to the point where I understand how modules are hooked, because at this point then I'd be ready to understand what this whole documentation section about modular options, that's so huge, by the way, right? Module options. And where is that stored away? In reference. Module option in reference. Oh, yeah, and that's just a huge page. And it says module as the primary method. There is a top level definition, at least. I don't think I've read that one. Primary method of configuring building of the package set. They are either an ATTR set containing. So just by that intro, now I feel like maybe I understand it better. The package set is the set of all the dependent package for your current focus of what you're trying to build, and and I suppose by specifying modules here, I suppose we override existing build instructions for specific packages. So then CUDA here has to refer to the CUDA Haskell library. And so when we say packages, it's not the Nix packages, it's the Haskell package set. And then the .CUDA means the CUDA package in our current package set. So how can I check this assumption? We have other things in our package.nix. Well, actually, that's a pretty big smoking gun right there. Packages has the CUDA ICTR set. So I don't think I even need to test it. Although it's interesting, we have NVVM here. Oh, because that's a Haskell dependency. Oh, interesting. Didn't realize that. Okay. Oh, version 0.10.00. Interesting. Why would it pick version 0.10.00? Oh, no, 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 hold on. I was looking at NVVM. CUDA is correctly 0.10.20. Okay. All good. And sanity still there. Okay, let's go back to Flick.nix. So here, though, we say now we're going to override some stuff for the modules, and we want to understand what this path means. Specifically, what are we overriding? And then I want to refer to where this replace extra library dependency comment came from, because I think it came from I think it actually came from the Flake thing. So tutorial getting started with flakes. And it didn't. So maybe in the creating development environment. And maybe just getting started. No. So maybe in the mapping on, yeah, probably here. Yes. In the mapping non-Haskell dependency to Nix packages. Replace extra library dependencies. And so this is specifically for this path. So what this tells us, I think, is, and actually I'm thinking of another way to check that, is that these paths are the way that probably stack2nix and cabal2nix interpret the cabal file and the stack files into a Nix record. I think they're called attribute sets, but let's call them records. And so if this is right, then maybe we'll be able to see a component library, maybe libs path for our top level stack YAML file in the S2N folder. And let's do components. Yes, there is a components attribute in there, and lo and behold, it contains a library field as well. So we have our .components.library path explained here. .components.library, yes. And so that refers to what? It refers to, I think, right, it refers to the library section in the cabal file. Meaning this. Since it's a translation of the cabal file and the stack layers into Nix, then we have apparently these are plugged to the components, the component field, and then I think what I then deduce by saying replaces extra library dependencies is that the .libs is library and underneath extra libraries or extra libs, which we don't have here. So how do we check this assumption? We say extra libraries CUDA right there. And we stack.nix. And check this out. And it has a libs, and it has CUDA in it. So we understand, and that's good. And then the question is, well, if we do that, then can't we just do that and then replace it by this module thing? Do that instead of the module thing. So of course we mutate our local cabal file, and we wanted to maybe avoid that, but we're playing with things. And I secretly hope that this is going to solve all our problems as well. You know, just another branch in the exploration of the troubleshooting session. It could be that because the dependency comes later, it actually won't work, because since the CUDA library is a product, is a dependency is an input to the build of accelerate examples, then it will be missing the CUDA stuff, so it won't work. And let's see in which way it's not going to work. It just say that it doesn't contain the package CUDA. Yeah, so let's get back our CUDA overlay in that case. Yeah, because here I had specified the package by name. So that all makes sense. I think I'm still continuing to understand. And also, I think I'm still continuing to understand that this would error here because this is still the kind of preparation phase. At this point, it's not even building. I think at this point, it's creating a derivation which contains the build recipe. And so before finishing to build, in order to write this derivation that then is later going to be built, it first checks that it has all it needs, that all of the inputs are accounted for, and so that then the build can start. Okay, let's do Nix develop. Okay, little apart here, because I sent a bunch of messages for International Women's Day to important women in my life. And if you're watching this, you should do the same thing. And yeah, I'm just moved by some of the stuff that I just received right now. And I didn't have the time to look into it more deeply, but I hope you have important women in your life as well. And of course you do. You have your mom, at least. I mean, if she's still there. Okay. Oh, so that I think makes sense. It proceeded, so it accounted for all of the things that it needed to have as in order to start the build process, right? And we told it, oh, we depend on CUDA, but then it was like, sorry, I don't know what CUDA is. And we're like, oh yeah, CUDA is CUDA Toolkit 10.2. And it's like, okay, fine. So now I built the derivation, and then it started building, and now it's kind of telling us, well, you were kind of lying because you told us that you gave us the derivation to build CUDA lib CUDA 0.10.2.0, but your derivation is not working. So this is expected, and this is good, and this is the world. The world is how it's supposed to be, and we can remove the extra library CUDA thing, and we can also comment back this line, and we can reintroduce our patching, which really this is what it is, the patching of the cabal file for CUDA 0.10.2 without touching the cabal file, which we can do thanks to this Nix translation layer. And this is really what this is doing. And the package lib mkforce, I want to actually read more about this because I actually used this before, and I actually didn't use this before. I used this before, and I'm using this currently in the shape of where we have specifically for our NixOS configuration for X server. I used libmkforce here to specify a Xserver config, a manual Xserver config, instead of expecting all of the services Xserver and the definition of drivers to generate one for me. Instead, I override it. So I suppose this is what it means, because I think Nix is by essence monoidal, meaning it just adds the thing to each other. So in essence, it means that you're never really overriding, you're always adding things. And I don't know whether that's true of every value, because obviously it's going to be different for a attribute set or a record, right? Where probably if you override an I mean, actually, I know that that's the case. If you override an existing value in the field, then you will replace that field. So it's not additive anymore in that sense. It's just a set, which is the semantic of a set. Whereas when it's an array, then it's properly monoidal. And in that case, I think if you specify another array and you say, well, all of my upstream things, like for instance, the library author has defined an array with some stuff in it. And now I say, yeah, well, I decide that the array has this stuff in it by default. So i.e., if I remove mkforce, it will just add the thing to the existing external libraries. If I say mkforce, it will erase the previous one and it will mutate it with the new value, changing the semantics of this monoidal, otherwise monoidal append set or array, I guess. It's not a set in that case. So what is it in math? It's more like, well, it's a set in math, whereas an attribute set is not like, it's also what is it? Well, I suppose it's an attribute set. It's a set where unicity is defined by a key. That kind of set. Okay. So a set with equality. Whereas here, I don't think you can, in an array like this, I don't think you can specify equality unless you have package equality, which you probably don't have. Although maybe you do, actually. Let's look at how mkforce is described in Nix documentation. Nix manual, sounds good. Let's try. Force one definition take precedence over the other, so yes. Function mkforce equal to mk override 15. Much puzzlement. Okay, let's not get into that rabbit hole. And so I suppose that that's not where we will learn about mkforce. And yeah, so that's an indictment of NixOS documentation right there. I would expect to see mkforce in some kind of API reference thing. So, or maybe it's an indictment of Google indexing. Let's not throw shade on Nix without knowing. But has this changed? No, I think I'm thinking of this. Yeah, I think there is a kind of a reference thing. There's the Nix expression language, and I think that that's more like a reference. No, that's a page in the documentation. So so that's not what we're after. So it points to the manual. NixOS manual versus Nix manual. Oh, right. So maybe I need to be a little bit more careful because maybe mkforce is going to be here, but it's not. Okay. So does this mean that there is a big thing missing from the Nix documentation? It's not a package, right? No. It's not an option. What it is something that's, I know how to find it in GitHub, but now I'm thinking more in like user journey. If I discover mkforce and I don't know much about Nix, then I'm not necessarily I'm not going to know that it's documented in probably the Nix packages, the Nix/Nix packages GitHub repo inside some lib folder where all the standard library is. I think the standard library and it's probably well, I'm sure it's well commented in there, but shouldn't the Nix library, shouldn't there be a standard library documentation generated from that? Sounds like it would make sense. There is a search here. Yeah, it searches in packages, which is also not right. Why would this search? I mean, I guess I suppose it gets us to a search page where you also have options. Okay, so unfortunately GitHub search, but maybe not. Maybe just GitHub Nix and NixOS Nix packages. And then here, mkforce. And now we don't have mkforce in here. Okay. So maybe the lib is a specific, is it, oh yeah, it's Nix. It's going to be Nix, I suppose. Although there was a lib, but no, test. Wah, wah, wah. So no, I think it was in Nix packages and it was in lib, and I think maybe now is there a default? There is a default. And there is mkforce. So yeah, so it's GitHub, so it's Google failing us, then GitHub search failing us. And because I guess everybody depends on Google to a large extent, and that makes me want to check whether DuckDuckGo has the same problem. And everyone depends on GitHub quite a lot if they're a developer and they know that they need to read the source in order to understand Nix, then they will be stumped by mkforce here. That doesn't even pick up the mkforce we were just seeing right there. So that makes Nix even less discoverable, and I think that makes it more of an imperative for automatic docs to be generated. And so this is going to be gotten from self.modules. So I suppose that means that it's in modules here. And that's correct. And all of this not picked up by GitHub search. So terrible. And it's MK override 50. Holy moly. That's what the documentation said that I bypassed because I couldn't understand it. And that's what it meant. Oh my God. So funny. The function mkforce is equal to mk override 50. Wow. So that's what it meant. It meant literally that mkforce is mk override 50. Okay, so I think some of these thoughts kind of require an issue open in the Nix repos. So let's do that. Let's be a good open source citizen. We use all these wonderful fruits of the work of amazing developers, and one simple way to give back is to give feedback. All right. So is that going to be Nix packages? The documentation we're looking at is the NixOS manual. So I'm not sure where to submit that. Okay. Generate documentation from NixOS, from NixLib. Let's call it standard library. I haven't seen it called standard library elsewhere. Nix packages library function documentation .ts. Made some major progress in documenting Nix packages standard library functions. Slow work. just that it's a work in progress. That's what's going on. Because this is actually linked from, this would be found by Google, and it is, well, it's not in the NixOS, so we haven't actually yet searched into Nix packages. And there's an argument that I don't know whether it should be. Maybe I'm too unaware of the history, and I think there might be some good reasons actually for this to be done this way. But actually, it's quite elegant to have the standard library part of the general open source library for all of the things, and not to set yourself aside. But I guess from a search perspective, maybe it's not the best strategy. But the fact that it would be in an appendix, actually, all of that makes quite a lot of sense. And so let's see if this function, for instance, is described. It's not. So I see, yeah, a work in progress and probably a daunting thing, and started in October 18. Over 25 functions. How many are there now? Oh yeah, we can count them maybe. Well, not completely easily. We can get a sense. 512. There's quite a lot of them. String manipulation functions. So I just fell into a hole right there, which is just tester instinct. You know, you just test the thing exactly with the thing that's going to break the assumptions of in this case, the documentation writer, and usually in testing the software developer. I just fell just right in the crack. I just tested something that's simply not there. But is MK override here? No, that one is not either. Okay. Roughly working on one each day. Good for you. In addition to adding this to the public docs, each documentation function has the link to where source can be found. GitHub. Yeah, that sounds awesome. Great. Yeah, people say it's great. Hasn't moved much from December 2018. Welcome addition. While this function appropriately documented the source files, having a central port for this documentation was certainly useful. Yes, indeed. Maybe we can help with this. Yes, after all, the library functions are mostly simple and easy to understand. I'd like to see much more documentation on packages functions. Are the numbers associated with make override setting the priority or ordering override? Yeah, I think that seems very likely. Yeah, I agree. I didn't dig yet because in the back of my mind, I'm like, am I gonna write the documentation for MK force and MK override? Oh, spam. Okay. Haven't seen spam in a while actually. Let's ban you. You're banned. Okay. Maybe they did a good job at banning those spam messages that had these weird characters, or did a good job. Like after a month of not doing anything, they finally added that to their banning filter. Okay, yes, MK override. Let's go look at the documentation and MK. That's not documented. Just in a broader section called properties. And do we have an MKF? We don't. Oh, I think these are constructors, the MK, like in the Haskell world. That's why they're called MK. So these are maybe kind of types. Interesting that none of that seems to be much documented. But yeah, priority of option defaults. Also, it's a kind of multi-layer. It's not just a just not a monoid. It has some priority capability. So uh, ordering capabilities in what's going to be able to override what. So if you do an MK forest, you're just a very high level override. So probably supposed to be used by users as we're doing now. MK default probably by library authors to set what are the defaults for the library, and option defaults. So hold on, priority of option defaults, priority used in config sections of non-user module to set default. Oh, right. So that's probably because in this ecosystem, you have lots of like wrapper packages that take a lot of lower level libraries and then wrap them in a set of sensible defaults. So I think those are the sensible defaults there, maybe. And then MKVM override is going to be like a system level override. So even more powerful. So let's say you've defined a user-based override in your configuration.nix file or in your the package you're working on, then you're going to be able to say, well, if it's in my kernel 4.9 VM, then I need to apply this override there, and it's going to be able to override the MK force. And then an MK override 0, which is called now strict. And then an MK fix strictness, and strictness here. So is there thinking that actually this is related to laziness in the way that strictness is usually related to laziness? And I think I was talking to someone on stream the other day where they were saying that there was another intermediary thing in there, which I forget right now, related to well, evaluation order for sure. Yeah, I forget. And then MK order is something else. There's an underscore type thing. Define types. I've seen that trick used before in JavaScript libraries and whatnot. And then there's default priority. And so MK order is not the same as MK override. And the default priority for things that don't have a priority specified is 100. Okay. And then we have alias definitions, and then we start to be documented again right there. So let's see whether it means that what's documented in the source code is what's documented in the documentation. And that's not the right one. The right one, keep that open. And no, so MK alias definition is not in there. Although a couple are MK alias, but not necessarily a lot of MKs, at least in that reference that you could see. Make overridable. Yeah, okay, I'll keep it in the back of my mind, but I'm not going to do a contribution for this. But I've definitely, again, leveled up in my NixOS understanding by understanding a bit what the documentation, where it is, and so on, and what its current state is. Okay. And I'll take a little break, and I'll come back and focus on solving this compilation issue. I think I have a lot of tools and a new understanding to be able to solve it. So I'm going to do just that. I'll be right back. All right, I'm back, and we are diving right straight back into CUDA stuff, um, Nix stuff, Haskell stuff, all the stuff. Um, so we found out that this notation is in fact patching the Nix, the Nix, the .nix products files that are created by the stack2nix tools that are part of Haskell.nix, and that allows to basically, in fact, in spirit, patch the Cabal files and say, hey, you maintainer of the CUDA library, you forgot to say that you depended on CUDA toolkit. So here it is. Okay. So that gives us a sense of, and in particular libs, and I wish this was called extra libraries. I don't know why, since this is mapped one-to-one to the extra libraries field in Cabal, then if you called it extra libraries, then it would be so simple to understand what it does. But now it's not. So, okay. Yeah, we even tested our assumption by adding a field in extra libraries and saw it show up on libs. So now I think it means we can revert to our Cabal knowledge and our stack knowledge, which is not very large, but to understand what's happening, because now it really depends on what Cabal does and the order in which it builds. And maybe therefore the difference between build depends and pkg config depends, pkg depends, and all that stuff. So I think I want to look a little bit into that. So extra libraries is meant to be a list of extra libraries to link with. That doesn't necessarily fit the bill in my, in what I understand about what linking to a library means, because in our case, we're really depending on the tooling that comes from installing the library, not necessarily the runtime dynamic libraries that we're going to link to. So I'm not sure. Oh, by the way, Swarm Collective, thank you. I'm glad that this is somewhat useful, that you understand some of Nix. Yeah, it took me a while, and I think there's not necessarily a lot of ambient content about it, and it's really smart. It's a really amazing layer on top of things. But I kind of jumped into it without knowing necessarily a lot about it, and so I'm really discovering as I go along. All right, so right, so let's look at build tool depends. Yeah, still not the link property, I suppose. Okay, fine. This is a really simple change to make. So I'll submit a change here. So that's supposed to be Cabal with the docs of developing packages. And here this is in package descriptions. So maybe there's a better reference here. So let's do extra libraries and see what comes up. It's probable that the developing packages thing has moved. We have Cabal install. We have quick starts, but that's for foreign libraries. That's not a good match. Extra libraries, that's really in package descriptions. I don't think there's much other places to look. Okay, so let's patch this. Extra libraries going to be this. Looks right, except we don't want the highlights. And I suspect that all of these other things are going to be just fine as soon as they are put underneath the Cabal package. source file URL. And let's test this assumption. Whoopsie, actually needed that. Give it back. Indeed, it seems like it will work. Let's be a little bit over the top zealous here and test all of the links. If we do link fixing, it looks bad if some of the links are actually not working. And okay, that's correct. That's all correct. So let's fix links to Cabal docs and what's the change? Make the docs better. And it doesn't take long, yeah? All right. It takes a context change, but that's all good. We were watching, we wanted to check out build tool depends. A list of Haskell executables needed to build this component. That's, no, Haskell executables. Executables are provided during the whole duration of the component. This field that doesn't mean much to me, but so this field can be used for executables needed during test suite as well. Okay, so the whole duration of the component, I think the whole life cycle of the component, of the component build, I think. Or does it also mean at runtime? It is specified by the package containing the executable. Ah, yeah, so it is a Haskell dependency. Build tool depends is a Haskell dependency. So maybe that's the main difference with extra libraries, is that extra libraries are not Haskell dependencies. And I remember my colleague mentioning something like that. Containing the executable and the name of the executable itself, separated by column, and optionally followed by version bound. Oh, so that explained the LLVM error that we got before. Yeah, so I'm now leveling up in my Cabal skills, because if I'll demonstrate, even for myself, that when we did NixDevelop here with this configuration, it told us that it was missing an LLVM column an LLVM-config column LLVM-config. Well, I don't know how it's specified. If it's a tool, it was missing that tool, and that it was a build tool dependency, which is exactly what we're looking at, right? Build tool depends. And so that's exactly that format. And now it explains it. LLVM, first of all, why there was a column there. I was actually puzzled about that. And the second part there is actually the name of the executable, and the first part is the name of the package. And so it makes complete sense that when we modify this, here we say the package, so the first part, but the executable is going to be the same, meaning LLVM_9 provides LLVM-config executable in the path. So it's all good. Awesome. Love that. Okay. And yeah, optionally version followed by version bound. All executable defined in the given Cabal file are turned as internal dependencies, as opposed to the rest, which are external dependencies. I think internal dependencies then mean my package as meaning a package that I define in my current project, the stuff that I'm working on. So let's see, accelerate example. It's not my project, but let's pretend that it is. If it had some Haskell executable there that I wanted to use for my build phase, then I would specify it this way. Okay, so can we use this for for the CUDA dependency, and would that be better? More, it could be more granular because the error for this was that NVCC wasn't there. So we could try something. Let's try something. Let's say that so it's not libs anymore, it's build depends. And how do we know what the option for build depends is? Well, our build tool depends. Well, we go into the module options and we do build tool, library build tools right here. And that's a list of unspecifieds. Okay, why not? And so build tools. Oopsie. Okay, something happened to my keyboard shortcuts. And then would I force it? I mean, actually, it doesn't really matter. I don't think I need to force it. So let's not force it. I don't know whether you can do this trick. Let's do it like this. And then the question becomes, do I need to specify the column thing? Where in which case it would be something like this column and NVCC. But let's just try like this and see what we get. And let's do it in here so that we can continue searching for stuff. Okay, so that's what build tool depends is. Cabal tried to make sure that all specified programs are atomically built and prepended on the path before building the component in question, but can only do so for Nix style build specifically. And so I'm still confused about whether Cabal Nix style builds are actually using Nix or not. I don't think they are. I think it's just Nix style. Okay, what do we get? We get a different error message than what we've had before. Is that right? We find the CUDA toolkit, but not this path. So it's not that NVCC is not found here. It's just that it's looking for this path. Oh, that means that NVCC, I think it's part of the ways that the setup.hs that we were looking at is trying to locate the CUDA installation. No, it's not, because it finds the CUDA installation. So it finds the CUDA installation, but then it misses the next step because it's expecting that that the CUDA library path is going to be at /lib64 because it introspects that we are an x86-64 system. So it found the install path, but not the library path. So I suppose that that's one of the things that specifying it as an extra library just deals with correctly. It provides the library path, probably by dealing with the fact that the -L is going to be properly specified with the actual path. Okay, that's fine. Plus, but it didn't complain on our syntax, which is, I suppose, interesting in itself, because yeah, we didn't specify any column thing anywhere, but it also didn't, error. But probably not the way to go. Okay, so that's build tool depends, and there's also build tool. Oh no, that's deprecated in favor of build tool depends. Okay. Okay, fine. And so what were the other things in the mapping thing? A PKG config depends. And I think that I have tried. A list of PKG config packages needed to build this package. They can be annotated with versions, and if no version constraint specified, is assumed to be acceptable. Kaba uses pkgconfig to find if the packages are available on the system and to find the extra compilation and linker options needed to use the packages. Yeah, that goes into the .pc files. But I couldn't find any PC files in the CUDA build products, so I don't think that this would work for us. Although it says if you need to bind to a C library that supports pkgconfig, then it is much preferable to use this field rather than hardcode options in the other fields. And frameworks is for Mac OS X, and then extra libraries is just this very terse, has this very terse description. A list of directories to search for libraries. Ooh. Yeah. But hold on, pkgconfig is a good candidate for helping us, which is why I have pkgconfig here, because that seems to indicate if we had a pkgconfig file, which we might not have, but that it would solve the C library being missing, which is the error that we have, right? Missing or bad C library CUDA. It could also be that because the way that that setup works, it uses this CUDA.buildinfo.generated. And that is that's one that actually I ported from Windows from the time where I was doing Windows. So it has like C program files path in it. And I actually don't, well, one thing is I don't know where the equivalent build info is generated. That could be in the Nix log. Or maybe at this point it hasn't yet generated one. That's also possible because it might, oh no, provide CUDA build info to override this using build information from CUDA build info generated. No, so it does do it, and so maybe I need to look at the Nix store inside the Nix store directly. But it tells me there is no such path. Interesting. I am going to close my windows because it is getting chilly over here. I'll be right. Okay, got lots of layers. So this is strange. But this is configure flags. So it could be that it simply hasn't even started to build there. So it hasn't even created the store in a kind of a Nix lazy kind of way. But there's an extra include dears here. So let's see. Yeah, I wish, could I just output this to some file? Or maybe even pipe this to more? Yes. All right. So okay, there's another path there. That's the CUDA toolkit path. Okay. So CUDA toolkit path is all good. So we see that it did configure the extra libdir correctly to the /lib folder, and so it does this because passing it as an extra library is, it seems at least smarter, but not as smart, not so smart that it can find the CUDA library. How come? Isn't that going to be exactly in that include path? Let's go check. We have only libcuda RT here. We don't have libcuda. How come? And that's, yeah, that's a slightly, that's the -lib store path. There's an include store path. Um, oh, yeah, and the include store path has a lib folder, which has other things, but not not what I would expect would be libcuda, but that might, but I'm not even 100% sure that that's the name of the thing. Right, and what I was saying before I get my layers is that I don't even know where the CUDA build info is, and it seems like that CUDA build info contains a lot of important stuff like the extra libraries and whatnot. But you'll notice that it doesn't say anything about CUDA RT, which would be expected to be provided. So maybe it is doing this correctly with this extra lib, except it's not finding CUDA itself. I suppose we could look at the CUDA toolkit derivation. Nixstore query, CUDA toolkit, maybe? --. No. So I think that that's the older version, but yeah, no, you need to have a derivation in there, I think. Yeah, my NixFoo is still not the best. Nix CUDA toolkit. And I want to find libcuda somehow here. Will I find this? I won't. No, of course, because it would be in common. We've seen that before. And aha, well, we see libcuda RT, and libcuda RT again, and libcuda. But what's going on? And then also If the library is already installed but in a non-standard location, then you can use the flag extra include dirs and extra lib dirs, which is exactly what is being done here, which is exactly what we're expecting would solve our problem, but doesn't. So I have to assume, in fact, that Haskell.nix does this. It doesn't have an extra lib dirs, right? Oh, yeah, I don't know what the keyboard shortcut for searching this terminal is. Lib dirs. Yeah, no, it's not. Oh no, it is extra lib dirs, and that's the thing. So that's the only lib that you provide as an extra lib dir, and it only has the lib could RT. And I don't know whether it's fair to expect some other files in there. And I suppose we can just download the tarball and check it out. That's the one. Except well, the tarball should be somewhere, and it should be unpacked somewhere as well. Isn't that? But I'm surprised that when we're looking at the includes folder, that's the one, right? That looks a lot like a unpacked tarball to me, with the EULA at the root and whatnot. Let's look at targets and x86NX. Yeah, so that just has includes, which has CUDA. And it has lib, which doesn't have. And it has lib, which has all of these things. Does it have all these things, including? Because that, you think that that would be also an extra libs tier. Why wouldn't it be? How come this dash lib thing in the store? So it might mean that the derivation outputs two things that are stored, that are in the store. How would we know that? It should be in command.nix. Is there a dash lib thingy? There isn't. With lib, maybe? Pass through meta. Probably not. Post install. Do these things with nsite. Prefix up. Postfix up adds the OpenGL run path. Post install check goes into bin. Check for the NVCC. Check for these files. Okay, we can maybe do a bit of that. So in here, you're telling me you're checking these bins. We see NDCC and DCC profile. Yeah, so probably that's the right thing. So it's the bin in this path in the Nix store. Where does that this dash lib thing come from? Is it CUDA toolkit itself, or is it some Haskell.nix magic that goes on at the moment where we say that it's a lib? Just install MVP. I don't think we care about that. Out CUDA samples. We do have the samples. In here, well, fix a path samples. Out/samples. But only if there are samples in the table, I suppose, is what this means. Oh, outputs, out, lib, and doc. There isn't a doc. Well, there isn't a lib here. Lib. See, it's a different store path. Okay, so if I resume where I'm at in this troubleshooting, I'm thinking that this requires a lib CUDA, and that there should be a lib CUDA in this /lib folder, because that's what's provided as a configuration flag in the extra libs directory. And so if it was there, it would be picked up. Okay, I could test this assumption by deleting this path in the store. And I don't know whether this is kosher or not. But, yeah, you probably want to sudo that. And you don't even want to do that. Okay, you're protecting me from myself. Fine. Wow, this is proper immutability, huh? No, I can't test this. I suppose I could add this /lib folder to the extra libdir path. And I think I should be able to do that by finding the extra libdir extra source files. Lib doesn't match. So libs, we have libs, sublibs, configure flag. So we could actually override the configure flag. Don't know that I want to do that. Include dirs. That's kind of, yeah, that's sort of what I would want. But not for sublibs, if that's possible. Not for exes. Foreign libs? Maybe it is a foreign libs thing. Oh, library, include dirs. Great. Let's try that. So include dirs. So the problem is I absolutely don't know how to specify the path here, because the path is supposed to have the Mixstore stuff appended to it. And I know how to do this in there's some cases in which I know how to do it, like What did I do? I just created a tab on that window. Yeah, in the context of something that is, let's say, for instance, here, right, unpack phase, in this double quoted section, multi-line string, dollar $src or dollar out, for instance, right, dollar out. Those all represent path for the local library. So I would hope that maybe it's possible to specify a path with such dollar thingy in it. And I suppose I shall try. I think it would be something like this. That would be the path to the package, I think. And then I could be saying, yeah, just also do lib, please. Okay, maybe not with a backtick. I think those are simple ticks. And invalid token, and so maybe double ticks. No Nix compilation error. So at least it type checks. Well, I'm not sure this all type checks properly because those properties there. Okay, different error. .libs definition entry 1. Okay, so yeah, I'm not sure this type checks properly because it says lists of unspecifieds. So as opposed to here, list of strings actually, right? So oh, I did this with the wrong thing. Include dears is here, and yeah. So let's try again. And same problem. Ici global C library code. And let's check our log. So this is the derivation now. And what am I doing? Why are you not going to the right screen? Nix log. Right, pipe that 2 more, and we get extra lib dears, which is with the /lib, extra include dears /include. No, that's still not what we want. And include dears indeed is different from lib dears, and we actually want lib dears, but we didn't see lib dears. Only saw. But the fact that they renamed library extra libraries to library.lib is also, why is it not? What's up with the alphabetical order here? Or am I, maybe I'm just a little bit tired. pkd config module main path. Keep sources includes. Okay, let's look at the library from the beginning. Library, Then let's drink a bit. Build tools, buildable, see source, configure. So configure flags is the other idea, right? We could just say dash dash whatever we need, right? And I need to search again here. I want to search include tiers. Yeah, it didn't work actually. What we did for include tiers here. So let's try configure flags. And the flag would be dash dash extra include, no, extra lib tiers equals this. And let's try. Don't know what these do things are. Movie profiling, shared static source files, frameworks, options, and same error. And then let's check the derivation, see whether we at least got a flag into the log. We did. Extra lib tiers. Okay, well, I'm really glad that we got that to work, and also including the extrapolation for the variable. Really happy that that's working. So now I'm thinking, do we have libcuda installed for real? Is it not going to follow the symlink? Should I actually put the symlink in there? Well, it's worth the double check, right? Since we know now we can actually do that. Let's just nix develop this time here. Maybe not here. I want to keep the pretty printing here. And I will order some food. I am quite hungry. Still building. And I see from the corner of my eye that it's finished building. And we still didn't build. Ah. Okay, I'll just be right back. Okay, I am back and the library is still missing. Where is the library? Where did the C library go? We don't know. Sorry, I'm still finishing eating my biscuits. I got a little bit of sugar in me. Where is Wally? Where is Kuda? Okay. So I'm curious to know whether this missing dependency on a foreign library message actually comes from the setup.hs. It doesn't seem like it does. So it might be coming though from the cabal machinery that goes around setup. Because when you talk about that you want a custom setup of sorts, what? I thought you needed, or maybe you don't. Maybe there's always a setup. I think you say, yeah, I want to use simple distribution. Then you depend on a whole bunch of Cabal machinery that usually is not available to you. It's done just with Cabal being configured with your Cabal file. And one of these pieces of machinery is the discovery of dependencies on foreign libraries. So this is a Cabal message. And let's, well, now that we have actually access to sending parameters to the build configuration flags, and let's just do a tiny sanity check here. If we nix log this, it should show the targets that we added just before the break. Okay. So also of some importance, I think it says libcuda here. And that's suspiciously like missing C library CUDA, isn't it? And the question is, where does this come from? And setup.hs would be a candidate for that. CUDA library path, extra libs. CUDA library path is that thing. Yeah, CUDA library, CUDA RT or CUDA. Okay, I was waiting to see something like this because then this maybe points the arrow towards CUDA toolkit not containing the CUDA library, which is kind of what? But you know, we're kind of searching in all the places, and this doesn't have a libcuda, and more importantly, I think this doesn't have a libcuda. This has a libcuda RT. So why is that so? Nix CUDA toolkit. Missing libcuda. I like this. Ah, so it's in the, oh, it's in variable. Oh, they put it in the OpenGL. Okay. Well, if that's the case, it's a strange packaging choice, but it will solve our problems, I think, because we know how to pass this flag to Cabal. So hopefully this is where we solve the problem. This is where Wally is found, or Nemo is found, maybe. Okay. We don't set LD library path blah. You can specify it on the command line for workaround. Why would you not do that? Because I suppose if, nah, didn't work. Let's look at the derivation. Oh, I had such high hopes for this. Log. Yeah, we do have this extra bits. Okay, so other possible option, LD library path. Ah, and all of the hmm. Ooh, right. I suppose that's very not, that's very Nix, but I kind of want to try it, see whether it actually works. No. Anti-library path. Following patches fixes it. Find out names, should I read .1? And then patch off. So you're patching TensorFlow here, I think. So they're working upstream here somehow. They're not referring directly to the CUDA library. They just patch, I think, the TensorFlow library such that it correctly refers to the Nix store libs. Yeah, I think that's the one that matches. So yeah, they're patching the TensorFlow library here. So it doesn't apply to us because we're before the dynamic linking phase. So our binary product should have the correct CUDA library. Okay, so not this, but this is also maybe promising because it would be nice to indeed have a PC, a package config file that I think would just point to the right places and in the system and whatnot. So libcuda SOS provided by the NVIDIA driver and blah. And, oh, what? Hold on. Is that what's going on? Is that why we... Oh, really? Hold on. If that's the case, then can we say packages and then Linux packages dot NVIDIA X11 here? That explains why that lib thing wasn't there. CUDA toolkit is only for the RT. Huh. Okay, well, that's pretty sensible. Or, it's a gotcha. I wish it wasn't there, but yeah, that raises my hopes just back up. And then we probably won't need any of that stuff. And well, it's building the NVIDIA Linux library, but the version 460, is that the one that we're, and then it gets the kernel on top, which I guess is part of that sandbox thing. 460.39, is that our driver version? No, it's not. So it's from unstable and we're using a different version. So that's definitely not going to work. I mean, it might compile, but the runtime is going to be wrong. And so let's not continue with that. I mean, we know it might still fail, but we want to pick the right driver version. And so which version am I picking up and how? That is in my configuration.nix, I believe. And I'm getting the Vulkan beta one. That's right. Well, makes sense. Very much remember that this for, and we don't need the configure flags anymore. Yeah, I was going to say very much remember that when I didn't pick the Vulkan driver, I had the 460 version. That was the one that was built. And so hopefully now it's in the Nix store, so you don't need to rebuild the whole thing. And you should be able to give us the missing CUDA error message a bit faster. I don't really believe that. I think we're going to solve it. No, that I saw some exciting package names there that made me think that maybe we solved the problem. But now, okay, it's downloading. I don't understand why you're downloading, but I saw libcuda there, so that's good. Okay, it's making, I guess it's compiling the NVIDIA driver too. Yeah, I think that's part of the whole reproducible thing, right? Is that it's doing some installation. I think it's part of the sandboxing thing. It's like when you do a build, configure phase, build phase. Da, 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 da. Okay. Yes, compiling. Yes. Ah, yes. Thank you. I did it. Finally. Recompiling. Recooking with gas. Things are fantastic again. All right. Well, on to the next error, right? Because that's often how it is. And well, yeah, and the next error is probably going to be that we're going to, in best case scenario, we build the executable, but when we run the executable, it's going to tell us that the CUDA driver version is not okay because we're running with a 11.1 version driver, but here we're building with CUDA 10.2, which means that in which case I will need to install a older version of the driver, and it could be that we don't have an older version of the driver that's Vulkan compatible. That's fine. We're not using Vulkan here, we're just using CUDA. So should be fine. But I guess I should just go back to the NVIDIA page, which gave us some compatibility matrix. Maybe I closed it, which would be very unlike me because I never close any tabs. So this is totally a gotcha though, right? The fact that you need to get the CUDA RT driver from CUDA Toolkit, but the CUDA library from the NVIDIA thing. Not nice user experience or developer experience. Okay, it's still building. Tools, we close stuff. Yeah, I can close that. Our manager, that's actually stuff that we haven't looked at during the stream. Oh yeah, that was yeah, so I'm not gonna go back up there. I'm going to relaunch my NVIDIA search for NVIDIA backward compatibility. And we shall find the good old table that will tell us here we're compatible. 10.2 is compatible only with 10.2, and that's 440. And then we'll go to NVIDIA Toolkit. No, not NVIDIA. NVIDIA X11 blah. Yeah. X11 Vulkan beta. Like so. And we want it in Nix. And it should be around here. And Vulkan. Okay. Well, it's not. It built. Bravo. And it should mean that embody. No, it's not. Maybe accelerate. And no. I might need to do. NixDevelop might not be enough to build the whole project. I thought it would though. Maybe because I didn't specify a build product. Maybe accelerate and body. No, dot accelerate and body minus a. You don't know these things. So I suppose stack build, which is going to use the correct flags this time, actually. I could even maybe cabal build. I don't think I'm really depending on anything stack-wise. And yeah, that seems all correct. And so that's going to do a bunch of things that I thought would be already done. By NixDevelop. So clearly I'm missing something here about what you do after you NixDevelop for a Haskell project, which I'm excited to learn about. But first I want to solve this Vulkan driver thingy. And that's not, it's actually going to be in the Linux packages, not in the NVIDIA hardware thingy, I don't think. And GitHub search is failing us again. Terrible. That's where we want to be, except at master. Vulkan beta is right here. And so Vulkan beta here is version 4.5.5. And so if we're lucky, we can go back in time in the Nix packages. And well, actually, we could also just override and pick the correct version from like make an overlay and rewrite these things so that they point to a driver version that's compatible with our kernel. Where are we with our building? Yeah, we're rebuilding stuff from zero. I wish that wasn't the case. Nix develop compared to Nix shell. And Nix run. Flex-based Nix shell replacement. 2019. Develop. The replacement is the Nix develop command, which uses the dev shell system flake output if it exists, or default package.system otherwise. Okay, yeah, so probably we're not, this is not correct. We're not doing things properly here. Okay. And yeah, dev shell or default package.system, that is what we're doing here, dev shell. I think, and default package, in fact. And I have accelerated body specified here. And there weren't much complaining when I installed it. So is there is no accelerate thing. And the accelerate and body package outputs, I think, an end body. No, that might not be the case. I think the executable name is accelerate and body. Source is whoopsie example, but yeah. So that should be the default package defined by flake.nix. And we should have a shell. Nix develop dot to open a shell. So maybe I've been using Nix develop thinking that was the smart thing, but I'm actually mistaken and it's dot. And it's not the same thing. Could be. Seems to be doing different things. Nix documentation. It's not going to be here because it's the new stuff. Nix develop. And that was a read the docs thing. It's not that. Okay, nope, still no accelerate and body available here. I think I need to say flakes. Develop. Finally run Nix develop. This is where we place the old Nix shell location. exit and run again. Yeah, so that's a bit of the difference, or something that I don't understand compared to the compared to Nix shell, is that it doesn't seem like I entered a shell. So if I exit now, I'm just gonna exit the whole. No, I'm not. So maybe it's just my prompt is not set up properly then. Set up a bash prompt for Nix develop. Def shell. Make virtual env before all languages. Nix develop. Already initially develop mkdev shell prints a welcome message. Welcome to mkdev shell. The shell menu, development server. That's nice. That's very, very UX focused. I like that quite a lot. Bash completion by default. Life is not complete otherwise. Packages that contain bash completion will be loaded by mkdev shell. Nix shell only develop mode. I like this quite a lot. How do I get it? Keep it compatible with Nix shell 0 and Nix Flakes. Clean environment, packages to the MK version, MK shell built on top of the system. This is why mkdev shall build its environment from a built-in derivation. DRM loads will change from DRM blah to DRM blah. And I've been trying to set up DRM in other environment that didn't work, so there is some kind of integration with DRM. And there's some environment variable. And some menu and a way to get back to the project root. Started. Okay, I want to see the flakes thing. Sorry. Is the flakes thing here? No. No documentation for the develop. Yeah. And what's up? 2 months ago, 22 days. So it's been actively developed. And I suppose I need to understand Nix develop in itself. So back to the Flakes twig series of blog posts. And let's try and see which one talks about Nix develop. Not this one. Not this one. Suppose I could have added it to. Yeah, come on, Google. Do this to me. Next. Okay, so none of the Nix example talk about Nix develop for some reason. Let's see. Maybe that came later. NixFlix edition. That's supposed to be. Anyway, yeah, okay, we saw this before. Yeah, it didn't help. And there is the same thing as this. Yeah. Using Unix Flakes for A reasons. Yeah, Unix develop. Dev shell is not a special one using combination with Unix develop, which opens a bash shell to give a derivation prepared. Of course, project shell using, for example, mk shell to also still work and not used here as well, either by using Unix develop with such derivation or Unix shell in combination with build-env. Unix develop always opens a bash shell. If you use ZSH, some workaround or relying on legacy Unix shell is needed for ZSH enabled shell. Using Flakes, the alternative is to use a build-env derivation, which is loaded using Unix shell. Unix shell? They seem to be using this shell here. It's going to rebuild everything. That's something I don't understand. Oh no, and body. Holy moly. That's right. So it wasn't compiling and body. So Nix develop uh, wasn't the right thing because it wasn't going all the way. It was preparing, but it didn't compile the actual examples. Because that's right. That's I'm happy to see that because that's an error of something I'm happy to be responsible for because I've been working on developing this. Nice. So we're getting to the code and like rising from the depths of the system and the library dependencies onto Haskell land where we can breathe a bit. We can breathe a bit, but I'm gonna have to look back at the original package to see how they did how they defined the bounce hat solver and comment out my code until I get the regular version to build. Examples and body, solver, bounce hat, and that's what it was. And that's what it shall be for a little bit of time still. And then next shell. Can't find source. That's a bit more. That's more related to let's delete some stuff we've added. NT, what was this already? The it's about the next stuff. So I might well, you know what? No. Let's just get rid of it. Can't find source. I think that's because I specify somewhere here a new module for bounce hats, and that didn't used to be like that. And that's because maybe I called my module differently. Solver bound. Yes, I corrected an error. There's a typo in the name of Barnes and Hut. So I corrected that, and maybe that's what then is creating some trouble here. But can't find source for solver Barnes Hut. You can find solver naive and naive one. So what would be the deal, the big deal in finding? I suppose if a sub-library was a problem, maybe then you would. I don't know. That seems a bit strange, but let's clean it up. And you're also looking from HS source that don't exist, but that's just warnings. But set up in examples and body. I can't find it. Examples and body, where it's right here. Oh, git status, examples and body. It's untracked. Git add examples and body solver. So that's a little Nixism that's definitely not obvious that you need. I think that's new. That comes with Flakes. That's a way to actually somehow be smart about what you want your build environment to really depend on. Like there's this commit phase that precedes it. So build, yeah, build phase. Nice. And so we can close this. Data constructor bounce hot. Perhaps even bounce hot importing from config. So visibly, some stuff are still not adjusted. And that's all good. That's Haskell, and makes me happy to see it. So much less of a heavier, intricate legacy ball of complexity than I have doing. Well, I guess it's the combination of Linux, Nix, Haskell, build systems. Build systems are just complicated, and I suppose that's it's fair. And okay, one more. That's a failing test, visibly. I'm a bit sad that this doesn't tell me it doesn't tell me the path. So, but oh no, it does because it's the compiling test, I think here. So anybody tests, and Barnes hut with the error, and it's not. So let's find the folder, hut, and I shall be right back. It's here in config. Barnes hut, and we want to probably fix that at some point. But, oh well, this point is now. And the Barnes hut tree, and Barnes hut Horizon. Barnes hut. Wikipedia. Okay. Now we're building. Right, and I was also looking at how I was going to import the Vulkan solver size. Advanced bodies. Okay, that's a bit annoying, but I'm gonna have to do nixlog, and yeah. And I'll be right back. And where are we? Build, and fails at the bounce calc accels. And body main, vector mass, bounce hertz, 21. Solver size. Equal type R. Is the code I lifted from accelerate change recently? Have this in the history. Accelerate. 6 months ago, no? Okay. Did I change main? I don't remember changing main. Importing bounce hertz. Select cells. Kilmash type. Oh, right. CalcXL XPR, XPR. Yeah, that's a different API. Hold on. So maybe actually the whole bar set thing was actually commented out. No, it's not commented out. Okay, and then the naive solver. Oh, but that's not the same as my naive solver here. How? Did I change this? I didn't change this. So which version do I have? How come this is a different version? Latest commit 2016. I changed the, oh, I did change the signature of this. I just ignore things. I just ignore them in the naive version. Okay, well, that's a way to trick myself right there. But hello, old June. You didn't, you made things easy for me right there. Because I decided to pass the size in addition to the epsilon somehow. Not sure why. But we'll get into this tomorrow when we actually do some Haskells. Yay, because in fact, the fact that we can just compile means that even if we can't run it, but I think we'll be able to run it. So it could be that this was a modification that I actually tried to implement but didn't successfully implement. Because this would be an int, apparently, according to the types. So very fine, be an int, and be an int here, and compile, please. Yeah, I was saying we'll get into and try to remember while all these changes were done based on the material we were reading to implement the bounce algorithm. And yeah, because the thing is, yeah, the bounce algorithm actually wasn't implemented or is not implemented in the accelerate example library. And one of my goals here, before I move on to other interesting things, building on the knowledge of how you can do basic things with Haskell and numerical computing on the TPU, is to contribute this back and then move on. Okay, it compiled. Yes, we have an executable. Accelerate embody. Is it gonna work? It shouldn't. But running some tests, doing some benchmarks. We never went as far as this. So this is the first time I see. And we have a core dump. And I think that's what we expect from the driver problem. So let's check our journal CTL and see what happened there. selected in body of user 1000.core. And yeah. So how do we view this already? View core dump with systemd core dump. Is there a core dump CTL maybe? I think there was. Yeah, core dump CTL. Core dump CTL. What do you do? You can list core dumps and wow, no shell. But yeah, we want that last one. And what else can we do with you? Get info about one or more core dump given a what? Match based on what? Info minus how, please? Well, we don't know, but okay, fine. We'll just give you some string to match on. Or do we need to do matching through whatever other things? Accelerate and body. How about that? That would be logical, right? But info is not. Oh boy. Okay, fine. Since or until, yeah, since -1, most recent entry only. There we go. And is that it? Oh, that's not a. Oh, maybe there's a path. Yeah, storage. There's a path. LZ4. Can we less this? No. Less LZ4. LZ cat. LZ4 cat. LZ cat. Boom. Not that. LZ cat. This thing. To less. And format not recognized. Yeah, so we do need LZ4. Okay. You'd think it's system installed if core dump CTL0 to use it, but maybe not. Exam -I. And let's hope it's in the top level thing, and it's not. So let's search for it. Sorry. Joseph, you said excellent, I suppose, because we built and we actually ran it and it failed, but we expected it for it to fail. But just want to check that it actually failed because of that driver error. I want to see the message because I want to be able to troubleshoot at this level. Yeah, nice. Okay, LZ4? Yes, LZ4. Oh, you're installing. Well, fantastic. Thank you very much. And then I should be able to run that thing then, except with A4. Oh, thank you. I hate you. Okay, LZ4 core dump viewer. How to debug core dump in LZ4 imager core dump CTL debugger. Invoke LDB debug core dump. I've never done that before. Well, actually, we do want -1, but we want debugger LDB. And that's, no, not info. Just debug. Fail to invoke LDB. Yeah, sure. So how about mixenv minus I LDB? Okay, you didn't find it. I wish you told me where you found the LG4 thing, because you did find it somewhere, but you're not telling me where. So I'm not learning from that. That's something I think Nix search solves. Nix search LG4, Nix packages. And it's installed. And there we go. We're in the thing. We loaded the core app. What can I do? I can attach symbols. Disassemble. Current command. Continue execution of all threads. Detach display. Expression at every stop. Jump. Bar. Show variables for the current stack frame. Okay. Bar. No. Okay. Core dump LDB. Practical LDB with core dump. Run the target program. Inspect the core code using generated core dump. Blah, blah, target create blah core blah. What? BTO. Can I do BTO? Yes. Likuda. So we're in thread. Why is it called accelerate embod? Is that we did launch accelerate embody, right? Yeah. Okay. It must just be some weird trimming thing going on. And so yeah, we are libc. So we only have, I know we have several threads. We have a thread with libc and doing some marshalling. Then we have a thread. This one stopped because of a SIG abort. So I suppose that's the main thing. And so marshalling, you know what? That sounds, and CU CTX pop current on libcuda, that sounds like it's trying to send something to libcuda and then it's not working because of the version. I mean, I might be, seeing things, but it's possible. And so this signal 0 stops. I suppose they're all stopped because the main thread has stopped or one of the threads has stopped. Or it makes sense. And libc6 here is cloning things. And we've got some unnamed symbols. There's some scheduling of tasks going on thread 6. Thread 4 and 5 only have a few things in there. That's doing some polling. Maybe that's kind of GHC stuff. And HS main with some arguments. So that's probably that's the main. That's the main access to main directly. And so yeah, I think LDB name symbol. It'd be nice to have the symbols. I think if we had the symbols, then we'd be able to know. But I think this is satisfying to me enough for doing one last thing before ending the stream, which anyway is going to mean that I'm going to have to restart the whole OS because I'm going to switch the driver. And that's reverting back to a driver version that is supported by CUDA 10.2. And so we said it would be a 440.33. And so one way to do this is to do blame on the Vulkan beta and look at what was the version before 455. And it was 455. Okay. What was the version before 455? It was 450. Aha, going back in time. What was the version before that? It was... They didn't exist. There weren't Vulkan things at this time, is what they think I see here. And yeah, okay, fine. So it means we're going to have to patch this manually, but I think we've done enough Nix things today that this should feel like we're continuing to apply our knowledge. So first thing is, where is that driver? Is there such a thing as the Vulkan driver for 450? It could be that this is so old it didn't exist and then we're stuck. Very possible. I didn't consider that. Vulkan 450.33. I think it did exist, and for some reason it's not a beta. There's not a different Vulkan beta driver. Don't know why, but that's maybe at this point it was integrated in the driver. It wasn't part of a different Vulkan. So let's check this out, because I think in the NVIDIA site you can download Vulkan drivers. And could be that we can go back in time in there. So indeed, that's the one that we're using. And then the question is, do you have earlier versions? And you do, plenty. Okay, great. 440, indeed. And that's the Linux version. And so let's zoom into this. We want 440.33. And 440.33 is not there. So that's not great news. If we go back, we see that before 440, we had 435. We had a 440.43. But apparently that wouldn't work with this version. But the 418, the 10.1, would be compatible with the 10.2, because the forward compatibility goes in that direction. So we could go a bit lower and go 435, I suppose. Not all the way down to 418, but I think this is the upper bound here. So 440.33. Yeah. So let's try to grab this guy. And is it still available somewhere? Is the question, right? How do I know that? We say NVIDIA download blah. And that's not from NVIDIA itself. That's what we're looking at. That's some advanced search. Drivers. That's not for developers, I don't think. That doesn't look either. Okay. So it could be that we just somehow patch. So how would that work? It will work by going to our configuration.nix And instead of this, we'd say something like hardware.nvidia.package is going to be some, well, in fact, instead of being this, can we call that generic function? Or generic is actually here. Also, we can maybe just call package. Only kernel now. Maybe DRM legacy kernel, call package kernel. So yeah, I think we need to pass it to the generic function. Let's see if there's instruction. Override Nix packages NVIDIA driver version. Yeah, I think I've seen that before. That's about pinning an older version of the. Oh no, it's not. Oh, that's strange. No, I think it is. It does go back in time, but then why do you also specify the tarball? Ah, right. No, okay. It's the tarball of Nix packages. So yeah, it's all based on pinning an older version of Nix packages. It's not overriding the downloading logic. How about here? It looks like you need to set config blah blah. Yeah. No, it's not. It's not right. Not very well. So let's get this version working. Okay, let's look at your code. Yeah, that seems to be referring to a lot of existing things. How to override default stable NVIDIA driver. Yes, still doesn't have any effect here. That is a copy of Stack Overflow. Annoying. Okay, yeah, so I think, well, I don't think people have done this. Oh, and my food is so close. I think what this means is that if I think generic outputs a package, so NVIDIA Vulkan 10.2 will be what we get, what we'll want to be a package, and that will generate. And we're going to need a whole bunch of let things that we're just going to lift directly from here. And I will start with generic, and it's probably going to tell us that it depends on other things, but maybe you won't need all of the stuff from generic. in which case we might be able to just be happy with the generic thing. And then what do we say? Well, we say the good old NVIDIA X11 Vulkan thing. Oh boy, I forget how to do copy pasting already. Not yank, or yank maybe. And then P, no. P, yes. And equals what? Well, equals, come on. Yeah, I definitely am a VI noob. And generic, right? And then those things, whatever they need to be, what do they need to be? Seems we need, why do we need a persistence D version? I see. I don't think we care about that. Patches, I see. I think we'll take the simplest, shortest, sweetest version of that and paste it. And then we'll say, well, the version we want is, what was it? It was 435.27.08. So give us that. And then we'll leave those SHA wrong, and we'll see whether we can even rebuild the system. Which, as with all Nix things, is not going to be doing any mutation. Yeah, and it'll gone. It's just going to. It's going to do. It's going to analyze our file. We're going to see whether there's errors or not. Like here, there are. And then once it gets all past these errors, it will run so that will create a derivation, which is a recipe for building stuff. And then NixOS rebuild switch will execute the recipes inside those derivations, build all of the needed stuff output of that, and then say next time you boot, well, you do the different things. You'll be changing what it can on the fly actually with switch. So, but that's not what our video driver is not part of the thing that it can be switched that way because there's a kernel part to the driver. So on next boot, it will load with the next the new things. Right. So I suppose I could, instead of ridiculizing whatever myself with my poor VI skills, I could instead do this like this. So std-env, I think we get from the environment. What I think we're supposed to get all the things. Yeah, this PKD is WLX thing. And a comma, I believe. And then some rebuild. And you still don't know what std-env is. So that's not the way to do this then, or maybe std-env is not passed to the module. Do we really need std-env? Maybe we don't, because I have the suspicion that we never go to this branch, and that we really just call package, in which case we don't need std-env. That's my guess here. Oh, I didn't save. Or you can't save because I need to retry a studio, I see. And then you still can't save because you need some ways to I see. Fine. Go back to VI and go at the top and then delete the whole file and then delete the whole file. And then maybe run Visual Studio Code in a studio environment, which apparently isn't recommended. That's all good, but you didn't say you wouldn't do it. Apparently you didn't do it. Okay, fine. I'll rebuild. And core package is undefined, and core package is meant to be given to us. Let's hope it's available in our environment. I know how to pass it, by the way, through the flake.nix file, but yes. Okay, fine. We'll do pure VI, poor VI stuff. I suppose I'm not completely clueless on VI. I'm just not good. Okay. See, he says and then screws up everything. Yeah, just I know how to undo. Yay, core package, yes, and rebuild. All right, core package was available, but config isn't. And I don't think we need config again, except where is, hold on, where was the error? Where am I? That's in modules.nix, so we attribute core package missing. Yeah, so no, so it's not there. So I need to pass it, but I don't know how. Maybe it's in lib. But then why wouldn't it be lib.core package? Okay, how to use core package in configuration.nix. Packages.core package. Oh, all right. Packages.core package. Packages. Package. Generic.nix, no such file directory. Yeah, I think that's correct. But why do you want generic.nix? Because you were importing generic.nix here. I see. And okay. We might need that. Yeah, we are going to need that. And that's all good. I suppose we can totally have a generic.nix right here. And have it have all the things and then rebuild. Except that assert apparently isn't. Oh, it's because the assertion fails? Yeah, it's because the assertion fails. Because I'm not clear about what the assertion syntax is like. The Nix packages docs, not that one. Nix packages manual. Yes, this one. And the assert. There we go. We are in it, right into assert. Assert one of blah blah, and there's no simple assert. How typical of my Nix experience. Huh. So actually, what we're missing is not the understanding of assert, which really just expects a bool, but it's the syntax of is the Nix expression language arrow and what arrow means. Update. Okay. What does arrow mean in Nix? Logical implication. I see. Wow, that's very fancy. And so you're saying not lib only should imply that kernel is different from null, but kernel is UR libs only and kernel is null. So I think maybe that's part of the stuff that we deleted, that we do want to pass you kernel equal null right there. Right, libs only is true, but kernel is not. So that's not right. So how is this supposed to work? Maybe 32 libs only. Let's see if libs only is somewhere else. It is. Kernel co-package. Okay, a hacky way of extracting parameter from co-package. Okay, I think we didn't add this, right? So I think we can do that. Whatever, I don't know whether that's going to work or not, but we need it. And you're back to call package, but we know how to deal with that now. And you're back to your problem with your assertion. So visibly it didn't work. If libs only else. So where is this kernel supposed to come from? I don't see it being passed when calling NVIDIA, but you have the kernel packages thing. So it could be that there's a whole other dependency somewhere. Kernel.version. So core packages imported. Don't know what that means. It's not defined here, so it looks like a keyword. Oh, if we believe the GitHub syntax highlighting. And generic, well, generic is a function, yeah, that takes these arguments. And Yeah, no, imported is this. So we don't believe the syntax highlighting from GitHub. Um, we call package with generic, and we call generic with the args. Hey Juan, how's it going? No chat ping, no, that's right. But I do have the overlay, but it's a bit small, and I visibly miss it once in a while. I'll try to put it a little bit bigger. Hey Sylvanator. Ah, too bad that you hate Haskell. Well, if you like Nix, we do some Nix as well. Actually, I've been doing more Nix than Haskell, you know. I'm doing good one, thank you. Today was an off day in Germany because it's pretty awesome that they have an off day for International Women's Day. So I hope you wished a happy International Women's Day to women that are important for you. Drink is available right here, and dinner is on the table over there. And you know, I'm caught into this limbo of like just one more thing. And so yeah, I've been doing that. Ich spreche keine Deutsch, the Silvanator. I'm afraid. I live in Berlin. I've been here for 6 years, and I don't speak any German apart from Ich spreche keine Deutsch. Yes, exactly right. My mom was one of the first ones, so that's definitely a go-to place. Yes, the German is awful as well. Yeah, it is a difficult language. That's true, but it's even harder when you don't try to learn it. All right. Okay, so we're doing just for you guys who just joined the show. What is this? Some drinking maybe being passed from one's cute little bird to another cute little bird. Oh, that's very cute. Yeah. What am I doing? Well, first of all, I'm more or less at the end of the stream, so very sorry if you're just joining. I'm going to be exiting pretty fast. We solved a big problem. Hey, thanks for the follow, Silvanator. Really appreciate it. I guess I should have the follow also here. That would mean that I don't have to do this. I could do this. But then I'll have tons of stuff on top of my screen. Anyway, I'm digressing. I was saying what I was doing. Actually, great stuff. I solved the problem that I announced as the title of the stream. A missing C library. Well, that error we squashed finally. I totally upgraded my skill level into Nix, doing so, and NixOS, as well as Haskell builds and Cabal and the Haskell.nix tooling that we've been using to do the glue. So super happy about that. And then so we get to the point where actually we get a compilable, well, no, a compiled executable for N-body thing, which is yay, because those of you who know, I've been trying to build the N-body accelerate program on a Windows machine for like a whole 10 streams, so probably more than a month or something. And then finally said, okay, enough with this Windows malarkey. I'm going to switch to a Linux system, and then went on to painfully try to install my new Linux system, NixOS, and just finally got things to be a little bit stable, and finally got to compile the first time the N-body problem. A source code that I've been looking at, hoping that it would compile and run for a while now. Except it doesn't run. It compiles. I mean, it runs, but it's, that's not true. It runs and it segfaults, which is better than it doesn't run. It actually runs a bunch of tests, but yeah, it segfaults. And I think the reason why it segfaults, and I was actually anticipating that, is that the version of CUDA, the CUDA driver that we're using, is more recent than the version of the CUDA driver that we're compiling for. So I can show off my NVIDIA stats there that say that we use this driver that uses the CUDA version of 11.1. And unfortunately, yeah, you've been here seeing it. I know you have. One follower of the first moments. Really appreciate your continued support. And by the way, did you notice that I actually pimped up the setting a bit? That was based on your feedback last time. I actually added back the microphone. I realized that I could unroll a cable from my music setup, and then I also decide after doing that I was like on a roll. I'm like, okay, well, how about I put up the camera and do the green screen, and this is where I'm at. And I guess quality level bumped up. And so yeah, NVIDIA SMI has the wrong CUDA version, so I need to downgrade my video driver. Because the other option would be to upgrade the CUDA library that I'm using, and that I'd like to that if I fail in making it work with the older driver, then I'll have to consider that option. And maybe one day I'll also upgrade the CUDA. I'll contribute an upgrade to the CUDA Haskell library, but most probable is that I'll switch out of CUDA and go to Vulkan, which is the open source version. Which will work on many other GPUs. And so that's the better, more portable way to do GPU programming these days. And I'm also happy to report that I can, that Vulkan properly works with this driver as well. So I'm using a beta version of the driver that has Vulkan activated. So I'm also ready to do Vulkan programming. And so was happy about doing all of these things with NixOS. But now what I was trying to do, therefore, just before going to eat my dinner, go Vulkan and Linux. Yeah, Vulkan only for AMD. It is not. Vulkan works. So I'm actually running Vulkan for NVIDIA right now. So and yes, Vulkan works for AMD, and better, Vulkan works on Metal. So it works on all the things basically, including Metal on iOS, for instance, with this adapter layer called Molten VK. So it's really the proper choice. Since Apple discontinued their OpenGL support, it's become the de facto choice. Plus, it has a whole bunch of optimizations. It's much more, it seems that you have learned for a whole bunch of these more proprietary approaches and set up something that is more usable, even though apparently much more complicated. But I probably won't delve too much into Vulkan low level stuff, because I use APIs to it. And that's where Haskell will shine, in my view, is that I can reuse all of the abstractions that I know with Haskell, and that will help me understand Vulkan even quicker than if I was reading about Vulkan itself. I think we will see. Yeah, it's good stuff. It's definitely good stuff. So that's kind of why we're trying to troubleshoot now, is this getting not Vulkan to work. We'll get to Vulkan stuff later, but before jumping onto the next best shiny thing, I wanted to make sure that I get the n-body stuff on the CUDA proprietary driver finally working, and then I'll feel good enough to move on to the next thing. Right, so this consists of trying to get this older version of the Vulkan driver installed on the system, and so I'm trying to build the Nix expression to do that, and since I don't know Nix much, I'm trying to get this to work. All right, sounds good one. Yeah, I absolutely will. See you on next stream. Have a great day. So let's see. We were doing NixOS rebuild switch. Hey, Joseph. Yeah, you're very welcome. Yeah, of course. that's what it's all about, because there's just long successions of troubles is what programming is. So learning and working in the open is going to result hopefully in some shared learning, and hopefully also at some point in some something a bit more easy to consume than a 5 hour 20-minute stream. And that's the problem that we're trying to tackle on the Saturday streams. All right. Oh, that's a different error. That is unexpected. Cache failure. But so maybe it's because I fixed something without realizing. How come? Okay, I need to go back to VI here because we actually shouldn't be pretending we're doing anything in here. And not configuration, like generic.nix. I didn't change anything in generic.nix, so it should be in configuration.nix. And I did add this kernel argument, but it was still failing just earlier. So why is it working now? I mean, working. It's not working, but maybe it's actually not actually doing a rebuild because we haven't changed. So maybe I need to touch my, let's see, NixOS configuration file. No. Okay. That is not what I was expecting. That is not what I was expecting. Let's make a little fake change here. And rebuild. Okay, now you're rebuilding, and now you have the error. Okay. So touch wasn't sufficient. You needed to mutate my files. It makes sense again. But yeah, we were trying to understand what's the relationship between libs-only and kernel. And it seems that what we have is libs-only being set to true, I suppose by default. Maybe. Yeah, I think by default. And then that should imply that kernel is not null. But kernel is set to null there. So what? So then obviously the assertion is going to fail. So now we need to understand how is this called in such a way that normally kernel is not null. And I think kernel here is not that kernel. It's some kernel that gets processed in generic.nix, which is here. And that's where the assertions are. And so maybe, yeah, there's documentation, yay. Whether to build the libraries only, i.e. not the kernel modules or NVIDIA settings. And indeed, that's not the case. We don't want to build the libraries only. So we want libs only to be false. But oh, that's how this is working. The associativity of NixOS, or the Nix expression language. This is passed to imported, which is generic. So libs only and kernel get passed to this. I see. And kernel if not passed, kernel is null. And lib, if true, false? Or is that the default? Like if libs only, right, yes. That if it's not defined, then that's how it's done. Okay. So when we call generic with this thing and we import it and like we in the configuration.nix we do something like packages dot blah NVIDIA X11 Vulkan beta. I need to check the other NVIDIA thing. There is another component, and maybe that's what's making this that's adding this change, because and maybe that's in the Linux packages. Not sure. NVIDIA X11 Vulkan beta, and yeah, this fails us. NVIDIA X11 Vulkan beta. We use this, but that's not where things are. Let's check where Vulkan beta is available. And it's only seen in here, which is wrong. Unless stuff is in NixOS. Still a bit confused. I mean, that's just because I knew this last week, I think, and then now I'm forgetting it. Right here, top level, all packages, NVIDIA Vulkan. X11 Vulkan beta. Maybe it's in the X11 package. I think it's in the X11 package. Display managers, maybe. I think it's in X11 and hardware. No. Video drivers. That's one of the ways. We're using a new way. Okay, I think actually that's actually in the Nix search options. Hardware, not NVIDIA. And that's a new thing that's in unstable. Yeah, it is, right? Ta-da. And NVIDIA derivation to use. And so that part of, yeah, that's the same thing we're going to. So I think this is just me using, I think I went down into, I mean, this is what we were just looking at, I think. Oh, no, it's not. It's not. So is there a Vulkan thing here? No, there isn't. So hold on. How does this work? Packages. NVIDIA X11 version. NVIDIA package is not it. MD package is not it. Module. Actually, package is it? package. Default config boot kernel packages. NVIDIA packages. Maybe we need to find NVIDIA packages. Well, I don't want to be elsewhere than in this repository. Okay, this might be still. Ah, no, there we go. And NVIDIA X11, that's the file. Pretty sure. Yeah, but except master. It's the same. It's the same file. It's the same file we've been looking at. So that's not the solution here. Okay, I think I need to eat some food and address take this tomorrow. Actually, that's going to be pretty fast. Or maybe I'll try to solve this either off screen after dinner, or maybe even on screen. We shall see. But yeah, that's it for me today. Quite a lot of wins plus skill level up and all these things. So thanks a lot, and I'll see you next time. Bye bye.